I'm very glad to welcome you to my course Angular Advanced, and I will be your instructor in in-depth study of this framework. In this course, I collected the most required topics in your everyday work to build technically boosted applications, themes that are most often asked on technical interviews and causing the greatest technical difficulties in understanding and explanation. So we will have a very interesting journey full of practice and simple explanations. In each module, we have practical examples where we'll touch the feature in reality and live code. In the content of this course, I will cover change detection, its strategies and peculiarities of work each of them. In the dependency injection module, we will dive deeply into injecting and providing dependencies, hierarchy of the injector, resolution modifiers, and provider case. I will show you in practice how it works and explain what opportunities this gives us. Then I will explain Zone.js and ngZone, how they are connected with each other, will show you how it works in the project, step by step, and explain how we can manually manage this work of the ngZone class. In the content projection topic, we will start working with the decorators that configure view and content queries. And also, we are not missing the most valuable features of the Angular 16, signals and standalone. In addition, we will cover micro frontends and module federation feature of Webpack to ensure micro frontends work. In scope of this theme, I am covering the different types of repositories organizing, monorepo and multi-repo, different structures of the projects, monolith, microservices approach, and micro frontends. I cannot miss the ways of the increasing performance with the Webpack and service workers. We will code and even make push notifications. I look forward to a pleasant and useful time and great success in your work. See you on my course. In this part, we are discussing the change detection mechanism and its principles of work. As we already discussed in Zone.js and in ngZone module, asynchronous operations in the application like event, request, promise initiates the invocation of the method tick on application ref class. It calls change detection to update the view, and during the change detection cycle, Angular goes through all tree of components and searches for all bindings, interpolations, re-executes all expressions, compares them to the previous values, and propagates the change to the DOM elements, if a change is identified. So in this way, it makes the synchronization of the value in class and template. But change detector has two strategies of updating the view, and it differs in rules with which change detection checks the elements in the tree. So we have two strategies, the default and on push. And by the way, we could apply the strategy separately to each component in our tree. And also we could combine in one logical tree of components different strategies. It means that the one component could have a default strategy, but its children will have on-push strategy. Then now let's take a look at the presentation. And here I mentioned the all rules for the each change detection strategy. The set of rules means if something from these rules will happen, then this component will be updated for the next change detection cycle. So from the left side, we have a set of rules for the default strategy. And the default strategy means that each change detection cycle, obviously, this component will be updated. And we have change detection cycle in the next cases. This is the common cases for Zone.js and then in ngZone when it calls change detection. So when any event occurred in the application or in browser, so it could be something from the browser API, it could be an event, it could be timer, promise, or request. So if the change detection cycle started, it will obviously update the all components with the default strategy. But we have a different situation with on-push strategy, and only 4 rules will mark this component as dirty It means that only in 4 cases this component will be updated by the change detection and will synchronize the value in template and in its class. So the first rule is when input value or reference were changed in this particular component. When we're working with the primitive values like string or number, if the input so the value was changed, the onPush strategy will mark this component as dirty, and next change detection cycle, the change detector ref class will update the component and synchronize its values. Or if we are working with non-primitive values, when we are working with the objects or with the arrays like also an object, if the reference to these objects was not changed, this component will not be marked as dirty, and you should be very attentive with this situation when you will work with onPush strategy. It means that when in your object just any field was changed or any value in array was changed but the reference will leave the same, it will not be updated the next change detection cycle because onPush will not mark it as dirty. So here we need to remember that the input value if it was primitive or a reference were changed if we are working with non-primitive values. So it is the first rule for the onPush strategy. The next point is event in component or its child. Means that, first of all, to follow this rule, this event should be tracked by this component. It's not just any event somewhere happened, like user clicked somewhere, but if this click is not processed, it will not be an event with help of which this component will be marked as dirty. So we should have in component or event binding, or any input or host listener, and when we have processing of this input, of this event, only in that case the component will be marked as dirty. And this is relevant not only for component by itself, it is relevant for the situation where the event occurred in any its child. And of course this event is processed by the child. So in this situation, when any event is captured somewhere in component, not only this component directly, but all of its parents are also marked as dirty. The third rule is async pipe emits new value. So the async pipe in itself has method mark for check. And when it emits new value, also this component will be updated the next change detection cycle. And of course, the fourth rule is manual managing of the change detection class. When we could manually mark this component as dirty with the help of the method mark for check, so we will change the value of the dirty and it will become true after the invocation of this method, and the next scheduled cycle of the change detection also will update this component. Or we could directly call the detect changes method, and this method will trigger the change detection for the whole application, and of course it will update this component also. So here we considered all the cases in which the onPush strategy will mark the component as required an update and when it will synchronize the values. And now I want you in more details tell about the event in component or in its child and how in that way with onPush strategy this component and its parent will be marked as dirty. Just for better understanding how it will be integrated into the full tree of the dependencies. So take a look at this tree, and here we have standard Angular application, very simple, we have a parent app component. It's the first main component in the application. And then we have two children of this app component. It's a header component and main component. And also all of them have their own child components. And in green color, we will have the cases when we have a default strategy. So here we have a default strategy for the all application, and if any event will occur, it doesn't matter when and how. So it means when change detection cycle will be called by the ngZone, it will update the all tree. And you should know that always change detection goes through the top to the bottom. So each time when we have any change detection cycle, the direction of update will be always from top to bottom. So you see that here the all tree will be updated. But then we have another situation. You see that I've marked the main component with on-push strategy, and also its children are also with on-push strategy. So profile component and details component are with on-push. And then let's imagine that on button component, we had an event. So this is an event which is tracked by button component. Let's just imagine that it would be a host listener. So we are listening for the click, and when the click occurred, so the ngZone calls the change detection cycle, and it starts to update from the top, the all tree. And then it starts from the app component. And then, as we have two children of the app component, the first one is header component, so it will be updated obviously. And then we have a main component with on-push strategy. And as you remember, to be updated in the change detection cycle, the component with on-push strategy should follow one of the four rules. So it's any input was changed or any event just in this component on or in its children, or a sync pipe, or we triggered it manually. But no any conditions happened for the main component. So the main component and its tree will not be updated in this change detection cycle. So now you see in the green color only the components that will be updated if something happened in button component. Let's take a look at the next example. Here the event happened on main component with on-push. So we have the rule that the event occurred in this component. So the on-push strategy, the on-push will mark this component as dirty. Also, we have an event, so ngZone triggers the change detection cycle. It starts from the app component, from the top, and then it updates the header component and its tree. And in main component, as this component is marked as dirty, so it requires the update, the only main component will be updated, but its children not. It will not cover the cases when the input for the children component will be changed. So if any input in profile component or in details component will be changed, of course this component also will be marked as dirty and updated. But in our case, the changes was only for the main component. So its subtree will not be updated. But the situation will be a little bit different if their event will occur in the profile component. And let's remind this rule about the events for the on-push strategy. So when the event happened in on-push component, it marks itself as dirty, but also its parent components, because it is very logical when we are required to update and re-render the child component. The child component is a part of the parent component, so it is logical that the parent components should be also updated. So in this case, the profile component will be marked as dirty and the main component as its parent also. So when the change detection will start from the app component, it will update the main and then profile component. But the details component will not be updated because nothing from the list for on-push updates happened. No new input, no event. in this component or in its child, because profile is a child of the main component, but they do not have any connection as a child and parent with the details component. So the details component will leave the same without updates. And then I've made some changes for the details component, and now it has the default strategy. And in this situation, the details component, of course, will update it, because the default strategy means that each change detection cycle, this component should be updated. So we have an updates in main component, and then with the true of the dependencies, it goes further to the profile and details component. So now we considered the rule for the events with on-push strategy and how the change detection updates the views with the default and on-push strategy, how on-push strategy marks the component and its parent as dirty. But also I want to take a look deeper to the other rule, the input parameters, when we are working with the primitive or non-primitive values, and also how we can manually manage the change detection cycles from the different components. And we will take a look at the practical project, and it will be the same as we now have on this presentation. It will be an app component and header and main as children components and they subtrees. So it will be totally the same. But from the beginning, I will comment out the main component subtree and leave only the header component subtree. But then we will return to the full application. And now you should see that we have already a visual representation of this application. The app component has its own counter. You see that it increments each 1 second. Then we have a header component. It increments also, but slower than app component. And button and filter components. Now let's take a look at app component. First of all, we have here the change detection strategy default. So the default strategy means that each change detection cycle, the values in the template will be updated. And of course, here we have for the asynchronous operation set interval, which invokes this change detection cycle. Each 1 second, it calls the callback, where we are incrementing this counter. And we counter have as with the interpolation in the template. So each 1 second, the change detection cycle triggers and updates the counter in the template with the value we have in class. So everything works fine. But what will be if we will change this to on-push strategy? And now everything should be changed. You see that time goes and nothing changes, and with the big delay, it is updated. But you should remember that for on-push strategy to be updated, we need to track one from the 4th rules, or input was changed, but we don't have any inputs in app component, or any event, but we don't have any events here, async pipe, but we don't have async pipe, and also we do not trigger this change detection somehow manually. But the value is updated. And here we should remind that the component could be marked as dirty and updated only when it's a parent of any other component, of any other on-push component. So we have a suspicion that somewhere in the child components was happened any event which triggered change detection and marked itself and the parent tree as dirty. So now let's take a look at the children components. And here we have only app header, app main I am commented out, And then we will go to the up header, and here we also have up button and up filter. So we should try to find something from these components. Let's firstly go to the first child of this up component. This is a header component, and the situation here is totally the same, because nothing is for the on-push strategy to mark the component as dirty, and of course to mark as up component dirty. So the answer will not be here. Then let's go to the button component. And here we have, you see, we have here the host listener click. So it means that if we will click on button component, this event will be tracked. But we should know that if we will click on this button component, it will track this event and mark this component and all the tree of parent components as dirty. But we do not make any click on button component, so the answer is also not in button component. Let's go to the filter, and here we have also a known counter. You see that it updates every 4 seconds. But here we have mark for check. So we are injecting the change detection ref class, which gives us an API how we could work with the change detection manually. And mark for check is a method which mark this component as dirty, and it means that next change detection cycle this component should be updated. But not only this component, but all its parent component. So it marks itself, the filter component as dirty, then header component as dirty, and up component as dirty. And all our asynchronous operations, all set intervals call the change detection. And when it was marked as dirty, the nearest change detection cycle will update the up component, the header component, and filter component. So the filtering component is the first entry point in these updates. The next example is when we will here, and then I want you to show how the clicking on the button component will update the button component, of course, and the tree of the parents. So now I'm clicking on button component, and you see that the value was updated, and of course the header and up component values were also updated. And then let's remove the commands for the up main. And here we have a little bit another situation. So here we have an input, direct input into the up main. So let's go to the up main, and here we will pass the value from the up component. You see that in up main it should be an input with the counter, so the same value of the counter should be passed in up component. Let's refresh. And then also I suggest to change the strategy to default, just to have an updated view each time when the app component is updated. And you see that now we are passing the primitive value as an input to the main component, and everything works fine. We always have asynchronized values in parent and child component. So then let's go to its children, to the profile component. And in profile component, we're also passing a counter as input. Let's take a look. We also have just a simple input, and we have the updates of the app component, main component, and profile component. So everything is okay, and the input for on push works fine. But then we have a details component, and let's take a look. First of all, we do not provide any inputs to the details component. Then let's see that here we have just an interpolation in template, And here we also have an updated value of the counter, but no any possibilities to update on push, because it is not a parent of any other on push component to be marked as a parent if the state was changed in a child component, and also nothing to be updated. So how we could update the details component? And of course, we could use mark for check as it was in the header subtree, or we could call the detect changes manually. Or which other ways we could change here the strategy to the default. Let's do it. And you see that now this independent counter also goes, and everything is updated. But also I wanted to show how it works with the non-primitive values, because you should remember that we have some moments about which we should remember when we're working with the objects. I decide to substitute the app details component with the reference component. So this is an app reference, and we will provide it here. And then if we will go to the app reference component, we see that it expects to receive an input, and it should be a counter object. We also have here an initial value of the counter. It will be 0, so we'll start from 0. And then let's go to the parent component. So we need to provide the counter object. So it will be an input. And also we need to create a value which we will pass here as an input to the counter object. Let's go to the main component, and here in the constructor I want to have a set interval. And it should increment a particular value. Let's create here a counter object. It will be a value. It will be an object with counter also. Here will be 0. And each 1 second we will increment this counter. And this counter object counter we will increment. And then we need to pass it as input. And now let's refresh. So you see that we have reference component here, but nothing is changed in the template. By the way, we have each time an updated value of the counter, but it doesn't reflect the template. And the problem is that now even if we will change it to the default strategy, let's check that we have in main component default, but on push component is not updated. So that's because we're working with the non-primitive values. If we would pass here just a counter to the reference component, it will work fine, but we are working with an object. So to make it working, we need to substitute the reference to this object. So the value of this, the reference to this counter object should be changed to mark this component as dirty because the input was changed. So we can do it in that way. We should here define the new counter object, and it will be an object with the counter field, and the value of counter field will be this. So now each 1 second the counter object reference will be changed and everything should work fine. Let's update. And now it works. So in all cases when you are working with the on-push strategy, okay, let's change it to the on-push just to be clear in our checking. It also works fine. So you should always remember that when we are working with the on-push strategy with the input values and you have an object in these inputs, the reference which you are passing to the component should have a new reference each time when it was updated. And only in that case, this component and its parents will be marked as dirty and the value will be synchronized. And at last, let's tell about the 4th rule to mark the component as dirty with on-push strategy. This is the using of a sync pipe, because the async pipe, when emits a new value, it also marks the component as dirty, this component and its parents. So now let's simulate this situation and let's go to the app component. And here we will create a counter as a stream of values. And it will be here the count async counter. And let's create this variable here. And it will be an observable. So we are calling the observable with the operator new. Here will be a subscriber. And with the help of the set interval, each 1 second we will pass a value to the method next of the subscriber. Next, and we will increment the counter like this. And let's add an async pipe. And also we should change the strategy to the on push. And I think let's comment out all this functionality. We will never need it. So now let's update. And you see that it works. We have on-push strategy. Nothing is happened from the list of the on-push except the emitting the new value. So no new input, no new event, or we did not manually trigger the change detection. We just have the new value in stream. And you see that everything works fine. So in these lectures, we considered all the ways how we could work with the default strategy, with the on-push strategy, and I think that now it became clear for you. And at last, I want to show you some ways how we can manually manage the change detection cycles, and we will work with the change detection ref class. We already worked with the change detection ref class in the filter component. We injected it into the constructor and we called method mark for check each time when the callback of the set interval was invoked. And it means that this filter component and all its parent component with on-push strategy are marked as dirty, and the nearest change detection cycle will update all the components with the default strategy, of course, and all components with on-push and dirty flag true. So with this method will be updated app component, header, and filter component at least. And also we have a method detect changes. It also is called on the change detection ref class. And the difference is that the detect changes method initiates the change detection cycle, as mark for check only mark this component as dirty and wait the nearest change detection cycle. But the detect changes manually call this cycle. But here we should remember that the detect changes will call the change detection cycle only for this component and its children. So it means that if we will call the detect changes on filter component, its parent will not be updated. Up component and header component will not be updated only if filter component will have children. And also these children should be from the default strategy. This is very logical because we call the change detection and it will be for default strategy components or for on push, but if they marked as dirty. It means that if filter will have children with on push, but nothing will be changed for these components, no inputs, no events in these components, this change detection cycle will not check these components. And we can make some checks connected with that. So our task will be to update the filter component, but from the header component. So we will call the detect changes on parent component. And also we will make some changes in app component just to see in which way the detect changes will update this tree. So first of all, let's go to the app component. And here we have the default strategy. Let's change it to the on push, just to understand that now everything doesn't work until the something will not be changed for the app component or until it will be not marked as dirty. So now it is not updated. Then let's go to the filter component. Here we have, we will comment out the detect changes, and we need to inject the change detection ref to its parent, to the header component. And we will call here this detect changes method. And in filter, we will still have an updating value, and let's maybe make it quicker. In header component, let it be also 1 second. So each 1 second, the header component will call the detect changes, and we expect that the filter component will be also updated. Let's refresh and see. We see that nothing works, and why? If we will go to the filter component, you see that it has on-push strategy. So the change detection cycle was called on this level, and then it has filter component as children, but it has on-push strategy, and it was not marked as dirty, so it was not affected the filter component. If we will change the default to the default strategy, now everything will work fine because it triggers on this level and then it go deeper and update the view of the filter component. But by the way, we still don't have any updates in app component. That's because the detect changes only works to the bottom of the tree, but it doesn't go to the top of this tree. So for app component, we also should or trigger manually the change detection cycle here, or to change it to the default strategy once more. So we can just try to call the detect changes also here. Of course, everything which is presented here is not a good probably practice, because we have a lot of lack of the performance. We have a lot of asynchronous set intervals, and in our case, the detect changes is redundant because we could just use the mark for check, and everything will work fine. We try it just for the understanding how it works. So now we know that detect changes works only for this component and for the children component, and also it follows the standard rules with the default and on-push strategies for each particular component, and update only children if it has on-push and marked dirty or default strategy. And also we have a way how we can opt out in common the ng zone and the angular context for some particular asynchronous operations. And now I want you to show, we a little bit touched this theme in the Zone.js and ng zone, and we will tell about the run outside Angular. And this is a method which gives us an ability to make some asynchronous operations, but without calling the change detection cycle. It is very useful, as I already mentioned, for the cases when we have any events in third-party libraries, and we know that nothing will be updated in our application, and we just don't want to call the change detection cycle, which will be for us not useful. We do not need to update something. So let's go to the app component, and here we have set interval. And first of all, we need to inject the ng zone class. ng zone, and we could call run this ng zone, run outside Angular, and then we could perform it outside of Angular. And also we need to return to the default strategy. And for the clear experiment, I need to comment out all these components just not to trigger change detection. So let's go to the app component and I will comment it out, and we'll work just with clear app component. So let's see that now the value is not updated. But if we will log it in console, we will see that the counter is changed to each 1 second, but we execute it out of the zone of our application. Let's refresh. And you see that the counter is changed, but the value is not updated in the template. So this is another way how we could work with the change detection with the ng zone. And also we have ways how we could in command detach the change detection. This is it is done with the help of the bootstrap module function, and we could pass here a second parameter with value noop, ng zone noop, and we will in common opt out the ng zone. We deeply discuss it in the module with the Zone.js and ng zone. And also we could detach the change detection for the particular components and then reattach. This is also a method of the change detection ref class. And at last, I want to show you some ways how we can manually manage the change detection cycles, and we will work with the change detection ref class. We already worked with the change detection ref class in the filter component. We injected it into the constructor, and we called method mark for check each time when the callback of the set interval was invoked. And it means that this filter component and all its parent component with on-push strategy are marked as dirty, and the nearest change detection cycle will update all the components with the default strategy, of course, and all components with on-push and dirty flag true. So with this method will be updated up component, header, and filter component at least. And also we have a method detect changes. It also is called on the change detection ref class. And the difference is that the detect changes method initiates the change detection cycle. As mark for check only mark this component as dirty and wait the nearest change detection cycle. But the detect changes manually call this cycle. But here we should remember that the detect changes will call the change detection cycle only for this component and its children. So it means that if we will call the detect changes on filter component, its parent will not be updated. Up component and header component will not be updated only if filter component will have children. And also these children should be from the default strategy. This is very logical because we call the change detection and it will be for default strategy components or for on push, but if they marked as dirty. It means that if filter will have children with on push, but nothing will be changed for these components, no inputs, no events in these components, this change detection cycle will not check these components. And we can make some checks connected with that. So our task will be to update the filter component, but from the header component. So we will call the detect changes on parent component. And also we will make some changes in up component just to see in which way the detect changes will update these three. So first of all, let's go to the up component. And here we have the default strategy. Let's change it to the on push just to understand that now everything doesn't work until the something will not be changed for the up component or until it will be not marked as dirty. So now it is not updated. Then let's go to the filter component. Here we have, we will comment out the detect changes, and we need to inject the change detection ref to its parent, to the header component. And we will call here this detect changes method. And in filter, we will still have an updating value, and let's maybe make it quicker. In header component, let it be also 1 second. So each 1 second, the header component will call the detect changes, and we expect that the filter component will be also updated. Let's refresh and see. We see that nothing works, and why? If we will go to the filter component, you see that it has on-push strategy. So the change detection cycle was called on this level, and then it has filter component as children, but it has on-push strategy, and it was not marked as dirty. So it was not affected the filter component. If we will change the default to the default strategy, now everything will work fine because it triggers on this level and then it go deeper and update the view of the filter component. But by the way, we still don't have any updates in up component. That's because the detect changes only works to the bottom of the tree, but it doesn't go to the top of this tree. So for up component, we also should or trigger manually the change detection cycle here, or to change it to the default strategy once more. So we can just try to call the detect changes also here. Of course, everything which is presented here is not a good probably practice, because we have a lot of lack of the performance. We have a lot of asynchronous set intervals, and in our case, the detect changes is redundant because we could just use the mark for check, and everything will work fine. We try it just for the understanding how it works. So now we know that detect changes works only for this component and for the children component, and also it follows the standard rules with the default and on-push strategies for each particular component, and update only children if it has on-push and marked dirty or default strategy. And also we have a way how we can opt out in common the ng zone and the angular context for some particular synchronous operations. And now I want you to show, we a little bit touched this theme in the Zone.js and ng zone, and we will tell about the run outside Angular. And this is a method which gives us an ability to make some asynchronous operations, but without calling the change detection cycle. It is very useful, as I already mentioned, for the cases when we have any events in third-party libraries, and we know that nothing will be updated in our application, and we just don't want to call the change detection cycle, which will be for us not useful. We do not need to update something. So let's go to the up component, and here we have set interval. And first of all, we need to inject the ng zone class. ng zone, and we could call run this ng zone, run outside Angular, and then we could perform it outside of Angular. And also we need to return to the default strategy. And for the clear experiment, I need to comment out all these components just not to trigger change detection. So let's go to the up component and I will comment it out, and we'll work just with clear up component. So let's see that now the value is not updated. But if we will log it in console, we will see that the counter is changed to each 1 second, but we execute it out of the zone of our application. Let's refresh. And you see that the counter is changed, but the value is not updated in the template. So this is another way how we could work with the change detection with the ng zone. And also we have ways how we could in command detach the change detection. This is it is done with the help of the bootstrap module function, and we could pass here a second parameter with value noop, ng zone noop, and we will in common opt out the ng zone. We deeply discuss it in the module with the Zone.js and ng zone. And also we could detach the change detection for the particular components and then reattach. This is also a method of the change detection ref class. In this video, we will tell about the most significant feature of the Angular framework, which makes it the most powerful front-end framework, and it is dependency injection. Of course, when you develop the Angular application, I think that you saw that in different entities, you need to use some other classes or services which already existed in the application. And you just injected it to the component or other class and used it. But the injecting of these dependencies is provided by the dependency injection mechanism. And DI is a pattern and a mechanism for creating and delivering some parts of the application to the other parts of the application that requires them. And take a look at the presentation. And here we have an example of the injecting the dependency of toast service in the app component class with the help of the constructor. So our class app component requires toast service. And now the task of the dependency injection mechanism is to share the already existed instance of the toast class rather than creating a new instance each time when it is requested. So in this example, will be provided the already existed instance of toast service from the injector class. Or if at the moment of the requesting this service was not created by injector, the injector will create it, store, and then provide it to the app component class. So the injector is just a layer between the dependency consumer and dependency provider. Now let's take a look at the very schematical understanding of what the injector class makes. So, when the Angular discovers that a component depends on any service, it firstly checks if the injector has any existing instance of that service. And if requested service instance doesn't yet exist, the injector creates one using the registered provider and adds it to the injector before returning the service to Angular. So our injector will create a toast service and just return the already created instance of the toast service. And when all requested services have been resolved and returned, Angular calls the components constructor with those services as arguments. And there are some different ways of providing the dependencies into the class. And the first one was already mentioned here on this presentation when we are providing it via the constructor. But we also have a new way of injecting the dependencies is just to use the inject function and providing the name of the dependency which we want to provide in this class. In the previous lecture, we discussed the ways of injecting dependencies. And now we will tell about the ways of providing dependencies. And before the dependency will be injected, it should be created by the injector class. And the first step is to add injectable decorator to show that this class can be injected. And let's take a look at the presentation. And here we have an example of marking the class as injectable with the adding injectable decorator before the declaring class user service. And the next step is providing dependency. And the way on how the class was provided depends on the level of the providing. Let's take a look at the diagram. And here we have a typical structure of the Angular application. We have an ng module, like main, root ng module. We have a main component, app component, which is the root component of the application. And we have a tree of the child components like whole component and user list component. And also all of them has their own tree of the child components. And the first option, how the dependency could be provided, is to provide a dependency at the component level using the providers field of the component decorator. And in this case, the user service becomes available to all instances of this component and other components, his child components and directives used in the template. And when you register a provider at the component level, you will get a new instance of the service with each new instance of that component. In this example, we provided the user service at the level of the user list component. It means that if we will create some different instances of this user list component separately, for each instance will be created an independent instance of the user service. But the child components like user component or details component will get the already registered instance of the service for their own user list component. So the second option to provide a dependency is to use the providers field of the ng module decorator. And if it is a root module, the service will be singleton for all other modules and components in this application. So in that case, you will provide the dependency on the application level. And this way of providing the service on the root level is relevant for the ng module-based applications. But when we have clear standalone applications, the same level of providing is to use the providers field of the application config object based to the Bootstrap application function. And here I have an example of the clear standalone application. As you know, in standalone, we don't have modules at all. Everything is components which are standalone. And to provide a service on the root level of the application without using the provider fields of the ng module, because we don't have any modules, we should provide it in the second argument of the Bootstrap application. So here I have a user service which is registered on the root level, and all classes, services, pipes, directives will receive only one singleton instance of this user service registered in that way. And the third option to provide a dependency is to do it with adding the provided in field with the value root to the injectable decorator. And in this way, we will provide a user service or any other service at the application root level. And with registering the provider in the injectable metadata also allows the Angular to optimize the application by removing the service from the compiled application if it isn't used. And this process is known as tree shaking. So in this video, we considered the three ways of providing the dependencies on the component level with the field providers in a component decorator. The second way is with the help of the providers field in the ng module decorator. And if we will tell about the clear standalone applications, this is a providers field of the application config object passed to the Bootstrap application function. And the third way is to use an injectable decorator with provided in root field. In the previous videos, we considered the ways of injecting and providing the dependencies in Angular application. And we also touched the question about the different levels of the providing dependencies. When we provide it on the component level, we need to mention it in the providers fields of the component class decorator. And in this case, the dependency will be created and shared only for that component and its child tree. If we provide the class on the root level, it will be singleton for the whole application. So the injector has its own hierarchy. And let's discuss it. On the left side, we have already known structure of the application. So on top of that, we have a root module, and then the hierarchy of the components. The root component, app component, it has two child components, home component and user list component, and they also have their own child components. And on the right side, we have the corresponding structure of the injectors. So each component here has its own element injector, and the all element injectors are in the same hierarchy and dependencies as their components. On the top level, we have the element injector of the app component, then the element injectors of its child components, and so on. And all of these dependencies are in an element injector hierarchy. And above the element injector hierarchy, we have the module injector hierarchy. And it consists of the root injector, platform injector, and null injector. But this module injector hierarchy is relevant to the module-based applications. It means that this is the applications where modules exist. But we already have a standalone applications, and this is in the case when we have a clear standalone components, no any module will be created in this application. And in these applications, the platform injector and the root injector are substituted by the environment injector and root environment injector. And of course, the difference is in the naming of the injectors, but also in the ways how the same injections are provided on the same level. Because we have modules in the module-based applications, and to provide a dependency on the root level in the module-based application, we just need or use an injectable provided in property to refer it to root, or we can use ng module providers array. But to create a root environment injector for the clear standalone applications, we need to just use the injectable decorator or to use the application config providers array. So some differences in the ways where these dependencies should be configured. If to tell about the platform injector and environment injector, for the module-based applications which has the platform injector, to provide it on that level, we need to mention or an injectable provided in platform, or we need to use the platform browser dynamic function. But we don't have the same function in the standalone components. And for standalone components, to provide something on the platform level, we also need or just use the injector decorator with the provided in platform field, or we need to pass the configuration as a second parameter to the bootstrap application function in main.ts in the place where the application is bootstrapping. So we discussed the injector hierarchy in the application, but we also could have lazy loaded modules, and in that way we will have some changes in this hierarchy. And if you will take a look at the presentation on the left side, I've added a child module injector. And it means that the all dependencies which were provided on the level of the lazy loaded module will be created in a separated child module injector. And these dependencies will become the singleton only for the hierarchy of this module injector. And it means that if we, of course, in lazy loading module will have a component and a tree of components, all of them will receive the same instance of these dependencies which were provided in the lazy loaded module. But in the case, if we will have some dependencies which were already provided in root injector, and we do not provide it on the level of the child module injector, all the hierarchy of the lazy loaded module will receive the same instance from the root injector. But it is relevant only for the cases when these injections were not, these dependencies were not provided on the child module injector. If we will have several lazy loaded modules, and in each lazy loading module we will have their own dependencies provided with the provider array in ng module, so all of the lazy loaded modules will have their own instance of the dependency. And now let's take a look at this slide. And now we will tell about the ways and the priority in resolving the dependencies. Let's imagine that we injected a user class to the details component. So this is the element injector of the details component. So in the very bottom of this hierarchy. But when the Angular starts to build the application and resolve the dependencies, it sees that its own element injector doesn't have the user service injected separately and independently for this component. And it goes to the parent element injector. The parent element injector is the user list component. And it also could not find the instance of the user service. After that, it goes to the next level of the components, and it will be the element injector of the app component. And if in this case also the particular instance of the user service will not be found, then it returns to the element injector of the target details component. And after that, it goes to the next level of the hierarchy. It goes to the module injector hierarchy. And the first injector will be root injector. And it checks if any particular service is already created on this level of the injector. And if no, it goes to the platform injector. Also, if nothing was found, it goes to the null injector and returns an error. And now I want you to show the use cases of the platform injector and when it could be useful for us to have a shared instance of service on this level of the module injector hierarchy. Because the most frequently used one is, of course, the root injector, when we are providing the data with the help of the injectable annotation provided in root, or when we provide it in the providers array of the module. So now let's go to the application I have. And here I have two modules, the counter1 module and the counter2 module, and of course a set of the TS and HTML files. And I also in main TS have the two times I'm calling the function platform browser dynamic and bootstrap the application from the counter1 module and counter2 module. And what will it mean for us? It will mean that in the application will be created two different small other applications on the same page. And if we will go to these modules, we could see that we're bootstrapping the application from the counter1 component and from the counter2 component. So it means that both of these modules and applications have only the common platform injector because the platform injector will be the same for the applications which are registered and passed to the bootstrap module function in the main TS. So they will be on the one level, and we need now to provide a service on the same level, so on the platform injector level. And I have a counter service here. And in the injectable annotation, I have the provided in platform. It means that both our applications will have the same instance of this count service. And now just imagine that we have any data in the one application and in the other application. And we want to make a communication between these two applications. And when in the one application we will increase the data, it should be reflected in the other application and vice versa. And how can we do it? And here in the counter service, we have a stream of data. And the only task of this count service is just to pass their new value to the next method of the data source. And then we need to have a subscription in both our applications with the new data. It means that when the application 1 will pass the new data of the counter, this data should be also received by the other application, and the template should be reflected with the new count. And of course, in the counter1 component, we have the method up, which will be increasing the variable from the component. and pass it to the stream with the help of the service. In the other component, in the other application, we have the method with down when we are decreasing also the number which is stored in this application. And also in both places, we have, of course, a subscription to this data. And each time when any application will pass the data to the next method in subscription, we will receive this updated number and will set our entire variable, internal variable of the application. And that's the usage case of the shared service. When we want to have the same functionality to share the particular instances of the services for the different applications on one page. And also here I want to mention some tricky case with the Zone.js, because for this particular case, for these both applications were created two different zones. And when something happens in the one application and when Zone.js triggers the change detection, the other application should not know something about that, and Zone.js will not trigger their updating. And it could be a problem if we want to have a synchronized data. So in this case, I've just used the method tick, and each time when the new data is received, the zone of the applications are triggered. And we can check, I commented out this method tick, and when I'm changing something in one component, the other component doesn't react, and vice versa. When we click the button on the not updated, of course, the data is updated and synchronized. But when we are working with the one particular component, the other application doesn't react. So this is just a small tip for you, that when you will have the two applications in one, if you will bootstrap it two times from the two different modules, you need to remember about the different zones and to share the service on the one platform level would be not enough to have always the updated data between the both applications. And now I want to cover the theme about the provided in any. But from the beginning, I want to remind you the hierarchy of the injectors we have in application. And when we inject any service on the root injector with the help of the provided in root or with the providers field in ng-module, we are registering the service on the root injector, and this service will become the singleton for the all applications. So the only one instance of the service will be created for the all application and shared between the other modules and components. And when we have the lazy loaded modules, for that separately lazy loaded module will be created a child module injector, and the root injector will be the parent injector for it. It means that when we will have any services which were provided only on the level of the lazy loaded module, it will be available only in this lazy loaded module, not outside of this module injector hierarchy. But in case when we have the service which was registered in the root injector, which is the parent for the child module injector, the lazy loaded modules will receive this singleton service from the root injector. And now let's take a look at the example. Here I have two modules. The main module is app module, and we have an app component. And also here in app routing, we have a lazy loaded module home. So when we click on this button, we are redirecting to the home, and the home component is projected into the app component, because here we have the router outlet directive. So we have a very typical situation with the lazy loaded modules. And then I also created the user service, and this service has provided in root. So it means that our user service will be registered on the root level injector. And then I also injected the service into the app component, so it's just injecting via the constructor. And also in the home component class, I've made the same. I injected it via constructor. So we are using the user service in our standard app module and also in a lazy loaded module. And now let's take a look at the console. Now, when we're firstly loading the application, we have only the one user service initialization. When we will go to the home component, this service was not initialized the second time because it was already registered on the root injector level. So our home component will receive the same instance of this user service which already exists in the root module injector. But if we will go to the user service and will change provided in root to the any, it will mean that separately for each lazy loaded module, the separate instance of this service will be registered specially for this child module injector. So it means that the separated instance of the service will be registered on the root level injector and also separately will be registered for each lazy loaded module. And we can check it. I've changed it to the provided in any. And now I will go to the app component. We see that the user service was initialized at once. And now we're navigating to the home office and to the home component. And here we see that the user service was initialized once more, just separately for the home module. So that's the difference between the root and any. In any, the service will be registered on the root level plus on the any module injector for the lazy loaded module. And now I want to cover the theme about the resolution modifiers. But first of all, I want you to remind how the Angular will resolve dependencies by default. And if we provided and if we requested the dependencies somewhere in the very bottom of this hierarchy in any component, firstly, the Angular will try to find the instance of the requested dependency in their own element injector of this component. And if nothing would be found, it go to the top parent element injector, then go once more higher. And if it will reach the highest element in element injector hierarchy, it will return to the target component and then switch to the module injector hierarchy. And also it will go through the root injector, platform injector, and null injector. And if nothing was found through this hierarchy, it will return an error and our application will fail. And the resolution modifiers define the rules how the Angular should resolve dependencies. And here we have 4 resolution modifiers. The first one is optional, and it gives an Angular an instruction what to do if Angular doesn't find what we are looking for. And it means if we provided a dependency on any level, with the resolution modifier optional, it will go to the null injector, and if nothing was found, it will return a null. So the application will not fail, it will just a null. So it prevents us from the failing of the application if we are not sure that this dependency was provided. The second resolution modifier is skip self. And in this way, we are instructing Angular where to start looking the dependency. And if we once more provided the dependency on the very bottom to the element injector of the, just for example, details component, With the skip self resolution modifiers, it means that the Angular should start looking for this dependency missing its own element injector. So it will start firstly from the parent element injector, and then we'll go to the top of this hierarchy if nothing would be found. The third and the fourth element resolution modifiers are self and host. And both of these modifiers are instructing the Angular where to stop looking. And if we have a self modifier, it means that the Angular will search only in the own element injector of the component. And if nothing will be found, it will stop and return an error. If, of course, we do not have any additional resolution modifiers, like, for example, optional, because we could combine optional and self, optional and skip self, and so on. And so the self resolution modifiers limits us where we should stop searching. And the last resolution modifier is host. And from the first point of view, it is very similar to the self. And also, we are limiting to the element where we should stop in searching in this hierarchy. And now I'm proposing you to take a look at a practical example with a host element, with a host resolution modifier. And here I have an Angular application, and first of all, an app component, which is the main root component of the application. I have a child component app library, so I'm using it here. And also from in this app component, I'm projecting the content to the app library. If we will go to the app library, to the HTML, we see the directive ng content, and this is the place where this content will be rendered. And in this case, our library component is a host component for the list of these components, because their content is projected to the app library. And this is the place where the host resolution modifiers could be used. Because, for example, we could go to the cartoon component, and the app library, as you remember, is the host element for the cartoon. And here I've provided in the providers field the library service. And also I'm calling the method from the library service. And of course, in this case, everything should work, because with the host element, with the host resolution modifier, we will search firstly in the private element injector of this element. And if nothing would be found, we will go to the host and then stop in this search. So in our case, the library service will be found just in the private element injector of the cartoon element. Also, let's go to the service to see that we don't have here the provided in metadata. So it means that we did not register it on the root level or on platform level. So this is an element which in our case will be here registered at least on the level of the cartoon component. And so we have the message from this service that serves with the book. If we will go to the library service, we have here just a simple console log. So we can resume that in this case, with the host resolution modifier, the instance of the library service was found on the private element injector, and it's fine. Now let's move it to the host element. And as I mentioned, the host element is app library. Let's go here, and I also provided it to the library service. And as we are calling the method from the host element, we expect that also it should be found. And let's check. We refreshed. And also the instance of the service was found on the host element. And also that's okay. And then let's try to move this dependency to the root level of the component. Because you should remember that the host resolution modifier limit the search to the host element. And if nothing would be found on toon component, then on host component, the Angular will stop in searching. So let's go to the library service, and here I will provide it in root. And now the component will be registered on the root level. So the method will not be called because the example or instance of the library service would not be found. And let's check. And you see that we have an error because no provider for library service was found in node injector. So it was not found on the own element injector, it was not found in the host element injector, and then it stops searching. So that's the example of the difference between the self, skip self, and the host resolution modifiers. And now I want to cover the theme about the resolution modifiers. But firstly, I want to remind you how the Angular resolves the dependencies by default. Let's imagine that we requested the dependency via the constructor somewhere in the very bottom of this hierarchy. And it is just a component on the bottom. And firstly, Angular will try to find this dependency in the own element injector of this component. And if nothing is found, it will go higher to the parent element injector, then once more higher, and when it reach the highest level of in the element injector hierarchy, it will go to the same element and then switch to the module injector hierarchy, and will go through the root injector, then platform injector, and null injector. And if nothing is found, it will return an error, and our application will fail. And in this case, we could start using the different resolution modifiers to manage how the Angular should start looking for the dependency, should stop looking the dependency, or what to do if the dependency was not found. So the first resolution modifier is optional. And in the example I've already told you, if we will add an optional modifier and the dependency was not found in the hierarchy, and the Angular will reach the final null injector, with the optional, the null will be returned and the application will not fail. So it could be an option if we are not sure if the dependency will be provided. The next resolution modifier is skip self, and here we are instructing Angular where to start looking. And if we are requesting the dependency once more in the very bottom of this hierarchy, firstly, it will miss its own element injector and will start looking for dependency from the first parent element injector. It means if we provided any service in the own element injector and in the parent element injector, the own element injector will be missed, and the value and the instance will be received from the parent element injector. But here, if nothing is found, it will go higher and higher, because with the skip self, we're instructing Angular where start looking for the dependency. Then we will go to the last group of the resolution modifiers, and it is self and host. And in this case, we are telling the Angular where to stop looking. This is the opposite meaning of the skip self, where we are telling where to start looking. So when we're using the self-resolution modifiers, it means that the Angular will search only in the own element injector of the component. And if nothing is found, it will return an error. Of course, we could combine some resolution modifiers together, for example, optional and skip self and optional and self. And if the dependency is not found with a self in the own element injector, but it has also an optional, so we also will not have an error, but just will have a null for this dependency. And the last resolution modifier is host. We also, in this case, instructing Angular where to stop looking. But with the host, firstly, the dependency will be searched in the own element injector. And if it missed, it will go higher to the host element injector. And now let's take a look at practical example to understand when we have host and what is host element. And here we have in app component, we have just an app library. This is a child component of the app component. And here in the app library, we are projecting the content with the other components, cartoon, novel, story, and desk. If we will go to the library component, here, of course, we have a directive-ng content, and this is a place where this content will be projected. And in this situation, we have a host element, and the host is app library, because the app library is hosting the content of the app cartoon, novel, and all of these elements. And the connection now will be between these elements and host element app library. Also, we have here a library service. You see that we did not provide it somewhere on the root level of the module injector, so it's just injectable without any metadata here. We have a read method, and we expect to have this simple string in console if this dependency will be resolved. And firstly, let's go to the cartoon component. And firstly, I've provided the dependency on the level of this particular element injector, because in the host resolution modifiers, we firstly start from the own element injector. And we expect that, of course, this service dependency, this dependency will be resolved. And we have the string service read the book. And everything is okay. Then we could move the dependency to the level of the host element injector. So we will comment it out. And then let's go to the library component and let's provide it here. And as app library is a host component for the cartoon, also we expect that it should work. Let's check. And it works. We have service, read the book in the console, so the dependency was resolved. And as you remember, we are limiting the level where the Angular should stop searching the dependency. And if now we will move the library service higher and let's move it to the root module injector, I will do it with the provided in root metadata. So in this case, the dependency should not be resolved and we should receive an error. So let's check. We don't have the dependency on the particular element. We don't have the dependency on the host element. We have it on the root module injector. And you see we have an error that there are no provider for library service found in node injector. So that's the difference between the self and the host and with the other type of the resolution modifiers. And I also want you to show the combination of the host and optional, because here we have an error and it's not a good way to have failed application. Let's add optional. Let's refresh. And we have a null, so we can make any checking here if the dependency is null to have any some other logic to capture this case. In this video, we will tell about the configuring the dependency providers, and mostly we will describe how to use classes as dependencies. Moreover, besides the classes, we can also use different values such as dates, objects as dependencies, strings, booleans, and the Angular provides the necessary API for us to make the dependency configuration flexible. We also could provide the one class and then substitute it by the another class, or we can just tell the DI that when you will create a particular instance of class, take the already existed one. So we have a lot of tools how we can manage the creation of the dependencies and providing the dependencies into the DI. And in this video, we will tell just about the provider definition case. And it will be a use class, use existing, use factory, and use value. And firstly, I would like to start with the use class. And now let's take a look at the practical example. And here in app module, I provided the user service in the providers array. And the app module is a core main module of the application. So the user service will be registered in the root injector hierarchy. So it will be the shared instance for the all application. And if we will go to the user service, you see that we don't have any metadata in the decorator injectable. So this is just a class, and the rules where it would be injected defines in a module or in the other class. So here we have the two methods, register user and update user. And we're following the particular interface where we should obviously have the register user and update user methods. So we provided it on the module level, and then we're using it in the app component class, injecting it with the help of the constructor and call the method update user. If I will refresh the application, we see in the console that we received the update user from the user service. So this is the log that we expect to have when the user service instance was provided for us when we call this dependency. And if we will go to the app module, we can substitute this way of the providing dependency in the other, and it will be the same because the current way of the providing dependency is a shorthand expression that expands into the provider configuration defined by the provider interface. And this form is totally the same as we will provide the user service and use class user service. We are removing this form, and it will be totally the same expression, so we could check that we still have the same log, same string in console log. So the use class provider key lets us to create and return a new instance of a specified class. And you can use this type of provider to also to substitute an alternative implementation for a common or default class. And this alternative implementation can, for example, extend the already existed class or just to provide an overwritten realization of some methods in this class, or emulate the behavior of the real class in a test cases and so on. And the possibility to substitute class with the other dependencies could be very useful in cases when you already have a developed application and you provided the service on any particular level, just in our case on the root level of injection, and then you use this dependency everywhere in a child components, and you're injecting it several times, and then you decided that you need to update the user service functionality or extend this functionality. And instead of substitution the injection in each component, in each class, where we could also cause the different problems with the compiling of the application with some errors, it is just a better way to make this substitution in one place, and it will affect the all components which retrieves the example of the service from the same level of the injection tree. And here I have just also an example with the updated user service. It implements the same interface like our first user service. And here we have another realization of this request user and update user class. So we have the string with the new name of the class. And we can do the substitution here with the help of the use class. And we should provide here the updated user service. So now we told the Angular DI that when you will create the user service dependency, just create and return the new instance of this class, and this instance will be the updated user service. And now let's check. We are refreshing, and you see that we have already the updated functionality of the user class, but we did not change something here in the injecting of this service, so nothing was changed in a child dependencies of this app module. So another option is to provide also a class, but which overrides the already existed functionality. And here I have the extended user service class. It extends the user service and implements the extended user interface. And here we will have a new class, add user, but also we will get the already existing realization of the request user and update user if we will not override it in extended user class. And I'm suggesting to override the method we are calling here the update user method. So let's override it in our extended user class. Override update user. And the new functionality here will be with a new string we will expect to have. It will be update user from extended user service, which override it. The user service. And then let's go to the app module, and here we will provide the extended user service. Let's refresh, and you see that in console we have the overriding the functionality of the user service. So it could be also useful when we want to use the same API of the class, but to provide any new realization in a particular already used methods in the component class or in the other services, which uses the same level of the injection. And also I want to consider the case when we have in the alternative class providers known dependencies which will be need for the creation of this class. Just imagine that our extended user service will have a dependency injected with the help of the constructor. And in constructor, I will inject the config service. This is a new service I've created specially to show you this example. And it will be a config service, then we will use some methods. Here we have the method makeName, and let's use it in our update user. We will use the name from this config service. We are calling the makeName, and we expect to have here Alan before this string. But if we will update now, we will see an error because there are no provider for the config service. Because here, when this class was created with the new operator, it required the particular dependency which was not resolved. So to avoid this problem, we could provide these dependencies here in this provider's array, and it will fix the problem. We're providing config service, refreshing, and we see that now it works. And now I want to consider the case when the extended user service will be provided and used directly in any component. Because now when we are requesting the user service dependency, it is substituted by the extended user service, because we've made it here with the help of the use class. And now when we're calling the user service, the updated user method will be used from the extended user service. But then I want to provide directly the extended user service and I want to register it on the root level. And I expect to have the same shared instance of the extended user service in both cases. Here, because it was substituted when the DI was created, the user service. And now, because we are just requesting the same instance. But in reality, we will get the two different instances of the extended user service, and we can check it if we will in console log compare the user service and the extended user service. Let's update, and we have false, because now we have the extended user service, not a singleton. And it's not a good situation, and the way how we could solve this problem is to substitute the use class with the use existing provider key. And the use existing provider key lets us map to one token to another. And in effect, the first token is an alias for the service associated with the second token. And it means that when in the component will be requested the user service, it will not create the separate extended user service instance, but will take the already existed extended user service, and we will make it the singleton. And now let's check. We have true, because the user service, in user service, we have the same instance we have in extended user service. So that's the purpose of the use existing, and this is just an alias for the second token. And instead of the creation of the new one, when this user service will be requested, we will just provide an already existed and registered extended user service instance. And also I wanted to show an interesting case with the use existing. And I went back to the project we were working with you on the content projection theme. And here we have in appComponent.html, we have a child component type library, and we are projecting the content. This is some components from, of course, our project: cartoon, novel, story, and desk. And in this case, the app library will be a host element for all of them. If we will go to the app library, we see that we have here ng content. So we are projecting the content of that elements here. And in a library.ts file, we are selecting the list of the elements with the content children decorator. And all of our components implements the same class. This is an abstract class book with the field pages and with the method show pages. Each class realize this method, and it's just assign a particular value to the pages field. In cartoon, we have the same in novel and the same in story. In the desk component, we don't have this realization, and it doesn't implement any class because the desk could not have pages. But if we will go to the host element, or not host, to the app component, you see that the desk also projects to the app library. And as all of our elements implements the same class, we could go to the host element and select only the classes we are interested in with using the class here in content children. So here we will receive the collection just particularly of the class which implements of the book class. And if we will go to these classes, you know that we could register a token with the name of the class it implements. And here, when we are working with the providers, particularly in class, the class in use existing return the instance of this component of this class. So everywhere we registered in providers the book token, and we are providing the particular class of each component separately. And what it gives us? If we will go to the host element, we could call the method show message, and to in one place to call the common functionality of the all elements which were collected in the books variable in this way. And you should see that after the 3 seconds, we will see the pages of the all elements, and you will see that the desk is excluded from this collection. So this is another way how the use existing could be useful for us and could give us an ability to work with the common functionality of the classes in one collection. And then I want to discuss the possibility how we could provide a particular non-class value like a string or boolean or any object which was created without the new operator associated with a particular DI token. And it could be useful in the situation when we want to provide a common configuration constants, such as, for example, any URLs or feature flags, and want to share this configuration for the all consumers in the tree of the injection. And we should register this configuration on the particular level of the injector to be used everywhere where it is required. And for example, we will now create a configuration with the base URL and with some flags which will help us to create requests and it will give us any base configuration of the request. And to start working with the use value, we also need to touch a question with the injection token, because to associate some particular value with any DI token, we need to create this token. And now I will create a file which will be named appconfig.ts. And here I want to create an injection token. It will be export constant, and I want to create appconfig. And I'm calling them injection token. And the interface I will define further, and the name of this token will be config. And then I want to create an interface, and we will define the request config. And here we will have two fields. The base URL, it will be a string, and cache flag, it will be Boolean. Then we tell that the injection token will follow this interface. And then we should go to the app module and then provide this token. Provide app config. And we want to associate this user with this injection token with a particular value, and we will use the use value, and we'll provide here the configuration. The base URL will be any URL, and cache will be false. And now we can go to the app component, and here we need to inject this injection token with the help of the inject. We are injecting the app config. And the interface will be request config. And let's check what we will have in the fields of the config. And I want to take the base URL. And let's see. So now we have this any URL available here in the component with the help of the injection token and provider key use value. So what we have here, we asked the Angular, when you will create the app config provider, just use this value. And when we will access somewhere this injection token, we always will receive the value which was provided in the use value provider key. The other way how we could provide the tokens could be the configuration which we could pass to the injection token. And now let's go to the app config once more. And here I want to extend the configuration, because here we also have some parameters. The second one is we can register this injection token on the level of the root. And also we could use a factory which will create for us this element. And here we want to return the value. It will be an object, and we should provide this value. So now we also provided the function which will create and define the particular value of this injection token. Now we can go here and comment out this provider, because we substituted it in the injection token directly. And now we can check that nothing should be changed for us. We still have the any URL in the base URL of the config provided to the app component. And the last provider key is useFactory. And we use useFactory provider key when we want to create a dependency object by calling a special factory function which will dynamically define which service should be provided instead of the requested one. And for example, here we are providing the user service and it is substituted by the already existed extended user service. But let's imagine that we have some configuration in our application, and depending on some configuration or depending on any value which already existed in DI, we want to define if to return or extended user service or just, for example, updated user service. And we should use this useFactory provider key. And let's do it. Also, I want to comment out the configuration for the injection token, because if we will go to the app config, you see that we already provide it in that way. We registered this token on the root level with the help of the configuration of the injection token class. And so go back here and let's make some changes. So when the user service will be requested from the DI, we want to define with the help of the function. And here we will rely on the values from the configuration, and if the cache value will be true, we will return the one service, if false, the second service. And first of all, we need to provide a config. And config will be the request config. And then we will return the config cache. If config cache is true, we want to return the updated user service. If it will be false, we will return the extended user service. And then for this function, we need to provide a configuration. And to provide the everything which could be used with this useFactory function, we are providing with the help of the arguments to this function, but we need to define the value of this argument. And to do it, we need to use the depth. And here in array, we will collect the all dependencies which we are providing here like an arguments. And as the first one is config, we want to provide here this app config injection token. And also we have a problem with the extended user service, because if we will see the realization of this class, we see that it has a dependency on the config service. So we need to provide a config service. And as we're passing the second argument to this function, we need also to define which particular dependency should be used to define the value of this argument at the moment when this function will be called. So we should provide a config service. And then we need to pass it to the extended user service. And that's it. Now we should expect that if in the configuration we will have true in cache field, the updated user service will be called. If it will be false, the extended user service will be called. Now we have false, so we expect that extended user service will return a value. And we see that we've gotten string from the extended user service. And now let's change the value to true. Let's refresh, and now the extended user service was provided when the user service was requested with the help of the useFactory provider key. How to understand that something was changed in our application and we need to update the view? What provides us this data update? And this task is solved by a Zone.js library. Let's take a look at this simple presentation, and we see that Zone.js is a layer between the application and browser API. It makes two important things. Firstly, it intercepts all asynchronous tasks, and second, it monkey patches asynchronous tasks. By the way, monkey patching is a way of program to extend or modify supporting system software locally, and it affects only the running instance of the program. And here we see if any asynchronous task happens in our application. It should be something from these three groups: macro tasks, micro tasks, and event listeners. It is cached by Zone.js. And Zone.js makes their own wrapper around this functionality, adding own functionality but saving the previous one. And then it provides it to the browser API and vice versa. So Zone.js library is just a layer that notifies the application that probably something was changed and we need to update the view. To understand it better, let's take a look at a practical example and let's realize Zone.js where we will monkey patch asynchronous task. Now it's time to make a simple imitation of Zone.js, and we will do it with setTimeout. And here we have a callback when we are logging console in console string invoke to have timer 3 seconds. And our task is to wrap this setTimeout with our own wrapper and monkey patch this setTimeout. It means that we will add a new functionality, but we will save the original functionality. And let's create a function. It would be patch setTimeout. And firstly, we need to save the original setTimeout. Then we need to redefine existed setTimeout with our own realization. And here we need to have the callback and timer just to have an ability to have an access to original callback and timer because we need to save provided functionality. Let's start with the string start. It is any our own functionality added around the existed one. And here we will call setTimeout old setTimeout, and in it we will call the original callback. And let's add that we are done. We should not forget about timer. And then we need to call this function. And that's it. Now let's invoke. And here you see that we have start, then 3 seconds, invoked, and finish. Let's do it once more. Start, 3 seconds, invoked, and finish. So in that way, Zone.js makes everything with asynchronous tasks which happened in our application, and it saves the previous functionality, add own wrapper around that with own functionality, but the original one is also saved. Now it's time to tell more about ngZone, its place in Angular application, And it's a good time to understand how it collaborates with Zone.js. As you remember in the previous video, we told that Zone.js is the layer between the application and browser API. It catches all asynchronous tasks and notifies the application that its state has been changed. But Angular doesn't work with Zone.js directly. The connection ensures in JSON library, which wraps the Zone.js. If you take a look at the presentation, you will see that in JSON is a wrapper around Zone.js. And application communicates with Zone.js through this class. And JSON injects to the root injector of the application, so we have an access to this class and its methods in application. The main task of ngZone is to fork existing zone and count all asynchronous operations in progress. So when any task occurs, Zone.js notifies ngZone and ngZone increases the counter. When the task is finalized, it decreases the counter. And when the counter becomes 0, ngZone calls method tick on the class application_ref, which calls detect changes for the all views we have in application. So the change detection cycle starts from that moment. Let's take a look at my own implementation of ngZone. It is very simple, just for common understanding. Let's go back to IDE, and here I've created my ngZone class. First of all, we've created a nesting variable which is equal 0, and it will be our counter. And 3 the most important methods: method onEnter, onLeave, and checkStable. Each time where the asynchronous task occurs, we go to the method onEnter and increase our counter. Then, when the task is finalized, we go to the method onLeave and decrease this value, and invoke the method checkStable. In this method, we make a very simple checking. If nesting is equal 0, it means that everything that started has already been finalized. Then we are checking that no any microtasks waiting in a queue. And if everything is true, we go to this line and our own microtask empty subject meets new value. And the other classes which are subscribed to this onMicrotask empty called the method detect changes, which calls change detection cycle for the all views we have in application. Now let's take a look at practical example, and I'm even in a very simple Angular application, and in appComponent.ts file I have counter which is equal 0. And I have a method onClick which will increase our counter each time when we will click button in our template. Let's go to our template. We have click event listener on button, and we have the actual value of the counter in our template. So we will always have we'll have an updated one in our template each time when we updated it in our class. And let's take a look how it looks in browser. And each time when we click, you see that we have, first of all, increment, and then change detection cycle updated the counter in our template. And first of all, to take a look how it looks in JSON class, we will go to the vendor.js file. And here everything starts. I've already prepared the list of breakpoints for you. Let's invoke it. And let's see, we've made a click, and first of all we came to the fork inner zone with Angular behavior function. And from that place everything starts. And on this line of code, we see that in JSON forks already existed zone, and the name of the forked zone is Angular. We will be interested mostly in 2 methods. The first one is onInvokeTask, the second one is onInvoke. And first of all, we came to the onInvokeTask method. Let's take a look at our arguments. And in task argument, we will have event name click, and we can check that it occurred on the source HTML button element, because here we have add event listener for the click. And firstly, we go to the method onEnter. And here, as I already mentioned, we are increasing the counter. So we counted this asynchronous task. So it was 0, now it will become 1. Then we go to the method onLeave when we are decreasing the counter. So now it should be 0. And then go to the checkStable method. And in this method, we are making a very simple checking that nesting is equal 0. Yes, because this operation was finalized already. No any other microtask pending in QM. Our zone is not stable. It means that the cycle of the change detection is not finalized, so our view will be updated soon. And then we go to the part try when we once more increasing the zone, because we also need to count the change detection cycle which will occur in future, but nevertheless we emit new value on microtask empty. Then we go to the method onInvoked, so we returned to the fork inner zone with angular behavior, and this method will be for change detection cycle. Let's take a look at callback, and here you see that we are dealing with application ref class and method tick. And once more we are increasing for change detection discounting, but nevertheless we're returning to the method tick for our first nesting when it became 0 for the change detection cycle. And here we have a loop, and we are looping through the all views we have in application and call detect changes for the all views. And from that moment, the change detection cycle starts for our application. Then we go back to the change detection counting. We are decreasing nesting, checkStable once more. Nesting is not 0. Our zone is not stable, but now finally we are making our zone stable because change detection already finalized. And of course we decreased it to 0 because now everything is finished. We updated the view and we've made our zone already stable. And briefly once more, click onEnter, increase nesting, decrease nesting, checkStable, it is 0. We are increasing once more, but we emit new value on microtask empty. Then we start a cycle for the change detection in this counting. We are increasing, but returning and call change detection for all views. Decreasing, checkStable, and making zone stable. In the previous videos, we considered the ngZone and its default behavior. And also I mentioned that ngZone is a standard class which is injected to the root injector of the application, and we can call different methods of this class. So ngZone provides an API to manage the change detection cycles manually. And in this presentation, we will consider methods run and run outside Angular. And the method run triggers change detection manually in the situation when change detection will not be called by default. It is very useful when we have any custom async API, because by default Zone.js processes only standard browser API tasks, but the custom ones will not be processed. Other method is run outside Angular, and it has the opposite meaning. It is useful for the cases when we want to opt out change detection for any particular tasks. For example, third-party libraries trigger async operations, but we know that for our application nothing will be changed and change detection cycle is unnecessary. So we wrap some third-party library methods by this method. And in addition, we have possibility to opt out ngZone for all our application. And let's take a look to practical examples. And let's go back to our Angular application. And firstly, I've injected ngZone class in the constructor of the app component class. And now we have an ability to work with the ngZone API. And I've created a subscription to onMicroTaskEmpty, and this is just to know the moment when all the synchronous tasks were finalized and we are before the moment when change detection will be triggered. It means that each time when our on click will be finalized and our counter will be increased, we will have on microtask empty in console, and after this logging in console, the change detection will be triggered and our template will be updated with the new value of the counter. And let's take a look. And we have on microtask empty firstly in our console, because change detection is triggered on initialization stage. It means that each time when our component is firstly initialized, change detection is triggered by default, just to align the values in our class and in our template. And then each time, well, all async tasks were finalized. Let's take a look. We're clicking on the button. We're logging increment in console. Our counter is incremented in the class. Then on microtask empty, because this async task is finalized. And after this, this string change detection is called and our template is updated. Let's go back to the application, and here I'm working with the run outside Angular method, and here set interval will be outside of ngZone context. It means that each time, each 3 seconds, when our counter will be updated with the new value, change detection will not be triggered, and we will have an outdated value in our template, but in the class we will have already a new value of the counter. But then when we will click on our standard click button and our default asynchronous task will occur, it will be cached by ngZone, and the value in our template will be updated with the already new value from the template. Let's take a look. We have on microtask on initialization stage, and then each 3 seconds we have a new value of the counter, but you see that it is not reflected in our template because no change detection cycles. And now if we'll click on the button, it will be cached by the ngZone, and we will update the value in template. You see that I've clicked, we have increment, then on microtask empty before the change detection cycle, and then once more it is increasing the value. Click, update once more, we have an updated one in our template. So that's the way how we can opt out change detection for any particular asynchronous tasks. And also, we can in common opt out change detection in ngZone for the whole application. And here in main TS in Bootstrap module, we can provide a second parameter, and it will be in ngZone with the value noob. And now in common in ngZone will not process our application. Let's take a look. No on empty task in console, because no change detection on initialization stage. And then when I'm clicking, you see that we're incrementing the value of the counter, but it is not reflected in our template because no any change detection cycle in common for this application. In this video, we will tell about the property decorator viewChild, its configurations, and the purposes for which we could use this property decorator. And the viewChild decorator is the most frequently used one in the Angular applications. And as we know, in Angular, we define a component template by combining the plain elements, plain HTML elements with the other Angular components. And let's take a look to the template of the app component. And here we have a child component, sublibrary, and some others: cartoon, novel, story, desk, and the plain HTML div element. So the app component is a parent component for all of these components, which are used in their own template. And sometimes app component might need references to the multiple elements or just to one element that it contains inside its template. in order to mediate the interaction. And just with the help with the view component, we can get an access to the elements from the own view. It means that in AppComponent class, we can get an access to any element which was used in the own template of the AppComponent. And in the other words, we can select or get a reference everything which was created by the own render function of the AppComponent. And now let's create our first view child. And we are using the decorator view child, and then we need to pass some parameters which will help us to select a particular element we want to get a reference. And this first argument to view child is named selector. So this is the directive type or the name used for querying. And there are 5 types of the selectors which we can use here. And the first one, the most easiest one, is just to use a template variable. If we will go to the template, we see that I've already created a book template variable, and we can get an access by this template variable. So we need to pass here the name of this variable. Then we will have a reference in the cartoon component, and the type will be cartoon component. So this is the first option, how we could select a particular component. The second option is just to use a component we want to get a reference, something like this. So the second option. And the third option will be selecting a provider defined in the child component tree of the current component. For example, it could be a reference to any service which is used in any child components. For example, if we will go to the cartoon component, we see here that in providers we're providing the library service. And in a parent component, in app component, we can get a reference to this library service, always also with the help of the view child. And here we need to pass the library service. It will be our selector. It will be in a variable which we will name library service, and the type will be library service. Then the fourth option is to make a selector with any provider defined through a string token. And it will look like this. In a view component, in a view child, we will pass, I don't know, any, just imagine that we have some token. It will be in variable some token, and it will be the type of string. And then the last option, the fifth type of the selector, is to get a reference to the template ref with the help of the view child also. If we will go to the app component, I've here created the ng template, and we can get a reference to this element just with the using and selecting by the template ref class. So it will be a class template ref in the variable template ref, and the type will be template ref of any. So this is the 5 types of the selector we could pass to the view child, and with the help of which we can select a particular element from the child elements which were used in the own template of the app component. And then if we will tell about the lifecycle hook, where it could be and when it could be used, and if we want to write any component initialization code that uses the reference injected by the view child, we need to do it inside the AfterViewInit lifecycle hook. So we need to implement AfterViewInit lifecycle hook, and here in the AfterViewInit method, we can just, for example, log the template ref and let it be an element ref. So it should be used somewhere not before the AfterViewInit lifecycle hook. It could be inside of this AfterViewInit lifecycle hook or somewhere in the other methods, but which will be called after the AfterViewInit will finalize their work. The second metadata property is named property read, and we use this property when we want to read a different token from the already selected elements, from already queried elements. And it means that when we are getting the reference to a particular component, we could go to the other elements which are in this component and just, for example, to select a particular HTML element in it which is delivered with the wrapper of the element ref, for example. Or we can take the view container ref of this element and dynamically create any dynamic component or any other type of component in it. And for these purposes, we are using the metadata property read and just mentioning which kind of node or which kind of entity we want to select in it. And let's do it with the example of the reference to the cartoon element. Here we need to pass an object with the field read, and our first one will be element ref. So here we will get a reference to the element ref of the cartoon component, and it will be lm the type will be element ref. We can take a look at it in console, and you see that we have a reference to the element ref, then we have a native element, and of course access to the old fields in the native element of the cartoon component. The second one is named the view container ref, and here will be the viewport, and the type will be view container ref. Let's update, and we have the reference to the view container ref. And the last one is a template ref, so we can access the template ref of the type here, let it be unknown, and here will be a template ref variable. So we can have an access to the element ref when we want to get a reference to the element in DOM, the view container ref when we want to get a reference for the Angular element, and template ref for reference to template. And by the way, also here we could read approximately the same things so that we can mention in the selector. So we can read a particular class with the component decorator or directive decorator, or we can, for example, get an access to the token which was injected into the child component in the provider's property. And the third metadata is named static. And it could be true or it could be false. And when we have static false, it means that we tell the Angular that we will make a search in a component with a dynamical view. And this dynamical view could be created or destroyed. For example, the directive in G4 or the directive in G if create some content dynamically, so it could inject, it could render something or destroy something. And in these cases, the view child will track the changes in LView collection. And when it will be changed, it could find this element and return the reference to this element. And if we use static false, the Angular will be instructed to make a check of this dynamic element each time after a rendering. So in the other words, each time when the render flag 2 will finalize its work. And only after that, the Angular will update the reference to a dynamic element. And also it means that the before lifecycle hook, like after view init, we cannot get an access to this node. By the way, when we're working with the render flag 1, for example, function, we can get an access in onInit function, but with the render flag 2 only when in the after view init lifecycle hook or even later. So now let's maybe read element ref. It will be the type element ref. And here the variable will be element ref. And then we need to pass a static here, and it will be false, for example, or it could be true. In this lecture, we will continue discussing the different property decorators in Angular. And now we will tell about the view children. On the previous lecture, we discussed the view child property decorator. And it is very logical, but the view children has the probably almost the same functionality as the view child has. But the difference will be with the elements which will be selected with a particular selector. With the view children, we will work with the list of the elements or collection of the elements which were selected with the particular type of selector. In view child, we worked only with the one element which matched the selector. So now let's create the first view children. And the first metadata property is the same as in view child. It will be a selector. And I also added I've made some changes in the template and added here some template variables to the different elements to have an ability to select as much as we could select with this template. And here also we will select by the template variable. It will be book. And by the way, the following selectors are supported like in a view child. It could be a template variable, it could be just a class with a component or a directive decorator, it could be a provider defined in the child component tree of the current component. Also, it could be a provider defined through a string token, and also just a template ref. So here no any changes, and we will use the template variable. Then we need to define the local variable, and it will be the book list. And the type of this element will be a query list. And we also will define the initial value. Something like this. So now in the book list variable, we will have all the elements which follow this type of the selector. So it would be 4 elements. And then I also want to make some changes with these selected elements. If I will go to the our components, we could see that all of them have the same property pages, just the different values of the values of the pages, and we see it's here. Let's check. And here in G, after view init lifecycle hook, by the way, we can do it before the callback of the after view init lifecycle hook will be called, because the view queries are set before this lifecycle hook, so we can do it in G on init, and maybe let's do it in on init. Let's make changes here in G on init. And here I want to go through the list of the elements of the L views that we selected from our component, and I want to make some changes after the 3 seconds. I want to change the value of the pages for all of these elements. And I want to use the set timeout. Here I will provide the callback, and I will go through the book list with the help of the for each. And here I want to change the pages value, and now it will be 1. And I want to do it after the 3 seconds. Okay. Now let's refresh. We're waiting 3 seconds and it was changed to 1. Also, the view children has the same second metadata property read, so it is used to read a different token from the queried elements. So we can read element ref, template ref, and view container ref, and also to get an access to a particular class or a directive. In this video, we will continue discussing the different property decorators, and in the previous video we discussed the view property decorator, and in this video we will tell about the content decorators, and it will be content child and content children. And the biggest difference between these two types of the property decorators is connected with the elements to which we are getting an access in the main component. And when we were working with the view property decorator, just for example, in app component, we got an access to the all elements which are mentioned like a child component for this app component. And it was app library or cartoon or novel, story, and so on. So all elements which are mentioned here in this template of the app component. But now when we will tell about the content child, the difference will be in the hierarchy of the elements to which we will get an access. And content child works only with elements which were provided in the content of the component. And content of the component is what we passed between the tags of the host element. And in this example, the host element will be the app library, and the content of the app library is this set of elements. And these elements are projected to the app library component with the help of the ng content directive. So here after the library will be projected the elements which were mentioned between the tags of the host element app library. So it is these elements. So to start working with the with the content child, we should move to the host element. So let's go to the library component, and here we can use content child. And the set of the metadata properties are very similar to the properties we had with the view property decorator. The first one is a selector. This is the directive type or the name used for the querying elements. And we also have the same 5 types of the selectors. And the first one will be the template variable. I already have here the book template variable, and we can select this element in app library. So we have here book element. It will be in a book variable. The type will be cartoon component. So this is the first option. The second option is selecting with the class with the component or decorative directive decorator, and we can just simply select it in this way. This is the second option. The third option is to select by provider defined in the child component tree of the current component. And if we will go to cartoon component, we have here in providers the library service, and we can select by this provider. We can go here and content child. We could select library service. It will be in this variable, and the type will be library service. The fourth option is to select with the provider defined through a string token, and it will look like this. We have some token. The type is some token, and the type is string. And the last option is to select the template ref, and so it will be in that way. The second property is the same property like in a view property decorators, and it is the read metadata property. And with the help of this metadata property, we could find another node which was returned with this selector, another LView, and just for example, any other HTML element which is nested or included in this selected main element. And we can take element ref, view container ref, or the template ref of this element, and it will look the same like it was with the view child. And let's read here the element ref. Element ref, and the name will be element ref. And the type will be element ref. So it also could be a view container ref when we want to return a reference to the Angular element, or it could be a template ref when we want to return a reference to the template. The next metadata property is named descendants, and we have it only in the content property decorators. It is absent in the view property decorators, and with the help of this descendants property, which could be true or false, by default it is true, we could tell if we want to make a search between the direct children of the host element, or we want to make a search in the nested elements of the host. If we will go to the app component, here we see that our host element app library has only the direct set of children, and this is this set of elements. And but if we will make a nesting like this, we will create a div element and move everything in the div element. And if we will go to the library component and we'll try to select it with the descendants property false, we will receive an undefined in console. And let's try to do it. Descendants false. So we are just telling that we don't want to search in the nested elements. We just want to make a search between the direct children of the host element. And then we need to track it, to check it in at least the ng after view init lifecycle hook. And here in console, I want to log the cartoon component, and it is in a book variable. And let's log it. Refresh. And you see that we have undefined here because we have a descendants false. So we only want to search in the between the direct children, but our cartoon is not a direct children of the host element. The direct children is the direct child is only the div element. It doesn't match the selector we have, so we have undefined here. But if we will change it to true, so we want to search through the all node tree of this selected element. And now we should have the cartoon component in log. So you see that the behavior was changed. And the last metadata property is named static, the same as in our view property decorators. And with the help of the static, we are telling if we want to search between the static or dynamic content. And dynamic content means that it is a content which could be created or destroyed in the process of the unliving of the component. For example, with the directives in G4 or in GIF, the element could be dynamically created. When we have a static false, it means that we will work with the dynamic content, and the Angular will select this element or update this element only when the render flag 2, only when this function will finalize it works. If we will work with the static true, so we expect to have only the static content and we want to select from the static content, the Angular will select this element when the function render flag 1 will finalize it works. And it looks the same like in a view content, and we could, like in a view child or view children, and it could be static true or static false. And the last property decorator content children. The difference between the content child and content children is that in content child we are working only with one element matched the selector, but content children will provide for us the list or collection of the elements following the selector. The type of the selectors are the same like for a content child. There are 4 types of the selectors. And also the set of the metadata properties are the same. The first one is a selector, then the descendants, which will help us to search through the list of the nested nodes if we have any nesting. And the property read used to read a different token from the queried elements. And now if we will go to the app component, I already have here the list of the template variables. And also we should not forget that we have here a nesting. And it means that for a content children, we also need to use the property descendants to just to search to find this element not from the direct children, but from the nested elements of the host element. And let's create our first content children. The selector will be book. And the type is query list. And also we are adding descendants. And in ng after view, we need life cycle hook. I will go with the for each through the all elements. And all of my elements have their field pages, and to see it here, 310. And I want to change for all of them to a particular number. And the field is pages, and let it be pages, one page. And also I want to do it asynchronously with the set timeout to see how it will be changed in the template. After 3 seconds, it should be changed to number 1. Three seconds, and now we have number 1 in the all templates for the all elements. And we did the same thing with the view children, but now we done it from the host element, from the library component. So we changed the place in which we worked with the content of the elements. In this video, we will tell about the different ways of the repositories organizing. And when we are talking about monorepo or multi-repo, we are talking about the repository structures and no more. Let's take a look at this simple presentation I've prepared for you. And in the central part, we have an example of the monorepo. And from the right side, we have multi-repo example. A monorepo is a single Git repository that holds the source code for multiple applications and libraries, along with the tooling for them. While these projects may be related, they are often logically independent and run by different teams. Some companies host all their code in a single repository shared among everyone. And monorepos sometimes can reach a very big size, and known companies such as Google, Microsoft, Facebook use their structures for for their repositories. Monorepos are sometimes called monolithic repositories, but they should not be confused with monolithic architecture, which is a software development practice for writing self-contained applications. Let's take a look at the presentation, and on the left side is presented the monolithic architecture. It doesn't connect it with Git, but with designing the application. And a monolithic architecture is a traditional model of a software program, which is built as a unified unit that is self-contained and independent from the other applications. And this word monolith is often attributed to something large and which isn't far from truth of monolithic architecture for software design. And the opposite of the monorepo is multi-repo, which is presented from the right side. It is also called polyrepo, and multi-repo is the current standard way of developing applications. a repo for each team, application, or project. And commonly, each repo has a single build artifact and simple build pipeline. And now the main question, how to choose which repository structure to select for your project. And let's name the advantages and disadvantages of these two structures. So monorepo is good in code reusability because monorepos encourage code reusability by allowing multiple projects to share common code, reducing duplication and ensuring consistency. Also, it is good in streamlining dependency management because managing dependencies is simplified as all projects share a single package manager and version control system. And it is good for cross-project refactoring. If you frequently need to refactor code across multiple projects, Monorepo simplifies this process by allowing changes to be applied consistently to all affected areas. But there are a big list of disadvantages of Monorepo. And first of all, I think that for small projects or individual applications that do not share much code or dependencies with other projects, using a monorepo may introduce unnecessary complexity. And also, in monorepo, we have a bad performance. We could have bad performance because monorepos are difficult to scale up, and commands like git blame may take unreasonably long times, and IDEs begin to lag and productivity suffers. And testing the whole repo on every commit becomes not very good. Also, we have a risk to have a broken main or master branch. For example, a broken master affects everyone who works in monorepo. And this can be seen as either disasters or as a good motivation to keep tests clean and up to date. Also, ownership, because maintaining the ownership of files is more challenging as systems like Git don't feature built-in directory permissions. And also have a complexity overhead because managing a monorepo can be more complex and might require additional tooling and workflows to handle dependencies, versioning, and build processes. And also, I think that the security concerns could be a disadvantage because there are no ways to restrict access only to some parts of the application. And if security is critical, separating projects into individual repositories can provide more granular control over access and permissions. And now let's go to multi-repos. And among the all multi-repos advantages, I could name a more lightweight cloning because multi-repos introduce a novel approach to cloning monorepos, allowing developers to clone only the necessary code. Also, in multi-repos, we have more optimized CI/CD because multi-repos architecture enables efficient CI/CD pipelines by building only the project affected by a particular change, minimizing build times. Also, versioning control and developers can easily manage shared libraries versions and configurations, ensuring project compatibility. And I think that simplified collaboration is a big advantage of multi-repos because collaboration remains straightforward as developers can work in familiar Git workflows without the complexity of single monolithic repository. So these two types of repository structures organizing like monorepo and multi-repo could be used for building micro frontends. Let's take a look at the presentation and let's consider historically how look our application. And from the very beginning, all our applications were monolithic. Monolith front-end and monolith back-end. But then backend suggested a new approach and separated the monolith to microservices. And it became very beneficial because now separated teams served each microservice and it started to provide more stable API and had a good compatibility. And then frontend also decided to use their granular approach in organizing the application structures because it could be very useful. And for that purposes was the micro frontend approach introduced. Thanks to Webpack 5, new feature module federation was provided, which builds different micro frontend applications like containers, then expose and consume code between builds, creating a single and unified application. And what it means? Let's take a look at the bottom of the presentation. And here we have main application shell and three separated applications, micro frontends, which are injected to the shell application. All his micro frontends have their own structure, build, and use different backends. And module federation feature builds each application delivered to the host shell application and share the dependencies between all applications in accordance of the settings. So sharing dependencies is the main and most significant feature of the module federation. It means that if you have Angular in shell application and Angular in micro frontend application, only the one instance of the library will be installed and shared between these two applications. It tends to the smaller bundle size. But of course, you could ask what will be if we have different versions of the same library in different applications, and how Webpack will resolve these conflicts. Let's discuss it on the next lesson. Before we start to discuss how Webpack will resolve conflicting dependencies, let's refresh our knowledge in semantic versioning. And I've prepared the version 2.0.0. The first number in this version is major version. The middle one is minor version. And the last one is named patch version. Major versions, as usual, are incompatible between each other because it is expected that they have breaking changes. But minor versions and patches are always compatible in the same major version, because in minor versions we as usual have backward new functionality. In patches, we fix bugs. And also on the right side is presented the package.json fragment. And here we have two libraries. The first one is mydep with version 1.0.0 with caret. Caret means that the NPM will check if the highest minor and patch, or at least patch version, is available for this package. And if it is, it will install the latest, but the major version will leave the same. Another dep package has the version with tilde, and it means that only the latest patch version is allowed for the installation. Let's go back to Webpack and resolving conflicting versions. Here we have a fragment from webpack.config file, where we set the useless lib as a shared library. Let's assume in our package.json we have versions like in option 1. Shell has a version with caret 1.0.0, micro frontend 1 has version 1.0.1 also with caret. Module federation will decide to go with the version 1.0.1 as this is the highest version compatible with both applications according to semantic versioning, because as you remember, caret means that the latest minor and patch, or at least patch version, is allowed for the package. In option 2, we have another situation. In application shell, we have a version with tilde, but for micro frontend application, we strictly have only the version 1.1.0. It means that in this case, the Webpack could not find any common version which is allowed for the both applications, and will install in fact two different versions. But module federation allows us to define libraries as singletons, because singleton will be loaded only once. And if there is a version mismatch, singletons prevents module federation from falling back to a further library version. And for this, let's consider the following version mismatch. In shell application, we have useless lib with version 2.0.0 with caret. In micro frontend, we have another major version with caret. It will be 1.1.0. And as we have useless sleep as a singleton, you see here that it was set as singleton in shell, and also we expect that it would be singleton in micro frontend application. It means only that in this case, only the one version is expected to exist in our application, only one version of useless sleep library. And to prevent loading several versions of the singleton package, Module Federation decides for only loading the highest available library, which it is aware of during the initialization phase. And in our case, it will be version 2.0.0. However, as version 2.0.0 is not compatible with version 1.1.0, accordingly to semantic versioning, we will get a warning. If we are lucky, the federated application works even though we have this mismatch. However, if version 2.0.0 introduced breaking changes, we will run into a problem and our application might fail. But at the same time, when we have just only a singleton field here like true, in our console we will just have a warning. But sometimes it might be beneficial to fail fast when detecting this mismatch by throwing an error. And to make module federation behaving this way, we should set strict version to true. It means that it will help us to prevent this versions mismatch on the earlier stage. And we will have an ability to align these versions in the process of development. And there might be cases when we know that a higher major version is backward compatible even though it doesn't need to be with respect to semantic versioning. And in these scenarios, we can make module federation accepting a defined version range. And it is presented on the right side. And here we could add required version with the allowed range of the versions. And let's assume that we have the same versioning like on the previous example. Let's go back. We have useless sleep 2.0.0, we have microfront 1.1.0. You see that we have the difference in major versions. But here we see that for microfrontend 1 application, major versions 1 and major version 2 is allowed for this application. And now we will not have an error in our console. It will just a notification for the developer that different major versions are allowed for micro frontend application. So I think that now it's time to practice with the micro frontends, and in this video we will create two applications. The first one will become our shell application, and the second one will be also an application, but one module of the second application we will integrate into the shell application like a micro frontend. And first of all, we need to create an empty workspace. So it will not be an application from the beginning, just an empty workspace for the creation and new two other applications in it. And for these purposes, let's use the command ng-new. Then the name of the module federation. And as we are not interested into the creation of the application, we will use the flag false. Okay, it was finalized, and what we have module federation new directory. And here we have two files. The first one is package.json. Let's take a look. We have here the version of the Angular is 16th version. Then in Angular.json, the content is very short of this file because when we will create a shell application and integrate a micro frontend and we'll use module federation feature from the Webpack, this Angular.json file, the content of this file will be changed, and all changes will be in this field, in the field project. Then let's go to this new directory, open it in terminal. And now we will create first one application It will be our shell application, ng generate application. It will be named shell, and also we need to have a routing. CSS. Okay, it was created. Let's take a look. Here was created, you see the directory projects, and the first project shell is included in this directory, and here we have src directory app, and this is our first component, and it is app component. We have app routing module here, and maybe let's add some functionality to this component. So I already prepared some functionality, and we will have button and two buttons. The first one will be shell application. So it will be expected that when we will press on this button, we will navigate to the shell component from our main application. And when we will click on the second button, we will navigate to the component from the micro frontend application. The next, I think that we will create now a new component for the shell application. Let's go to this directory and let's create a component, ng generate component. Let's name it maybe just shell component. Okay, we have it here. Let's add some information. Shell component from shell application. And the next, we will configure our rules, and with the empty one, we will have component shell component. Okay. Then let's go to the app component, and here we need to use router outlet. So it will be the place when our routes will be changed each time when we will click on this button, and we will be switching between the shell component, our shell application, and the micro frontend, which will be delivered from the other second application. The next our step will be to create a second application. Let's go to our main workspace, and here let's generate app, and let's name it micro frontend. It will be mf with also with routing. Okay, it was created. Let's go to this new directory. Then let's go to the app directory to create a new component and new module for the micro frontend application. And let's create firstly component ng generate component. Let it be a high component. And also let's add a module high, and it should have routing. Okay. Let's add here some content into the template, and high component from mf. And then in high routing module, when the path will be empty, we will load component by component. And in uprouting module, for the empty path, we will lazy load this module, import high module ts. Then let's take this high module and in template we should not to forget to provide router outlet for our routing. So now we have two configured applications. It looks like a micro frontend and shell application in the directory projects. And then let's return to the module federation main directory. And here we will use the command for the architecturing of the shell application. And it looks like in G add Angular architects, module federation, and I strictly mentioned the version of the module federation because we are using the version of the 16th version of the Angular, and I want to have the same compatible version with the main Angular version. And we're telling here that shell application will be on the port 3200, and the type of this application will be host application, and means that it will be the main application. Okay, it's done. Let's see what we have now. In shell application we have, and in webpack.config.js file we have some default configuration, and in remotes, firstly, it is the name of the micro frontend which we want to inject into our shell application, and by default the local host for the remote application is 42.00. But we will use the port 4201 for the remote, and for the main application it will be 4200. So we corrected here the port for the remote. And in shared part, we have their configuration for the singletons, and we expect that their all packages will be singleton, and also only the one version could be used for the shell and micro frontend application. This is the strict version true, and required version auto. And now let's configure our micro frontend application. And for that purposes, we will use very similar command in console. And but the difference will be in the name of the micro frontend, because the project will be MF, the name. Then the port we will configure 4201, and the type will be not host but remote. So it is ready. Let's take a look to the new webpack.config.js file into the micro frontend application. And the name is MF, like it was named in the shell application. And in exposures, we're mentioning the part of this application which we want to use as a micro frontend. And in our case, it will be the whole module. And the name of module is a high module directory high, then high module.ts. And also let's name it high module. The same configuration that all packages are singleton, and only the strict versions are required for both. Now I'm suggesting you to take a look to the Angular JSON, because as we already configured the shell application and micro frontend application, the Angular JSON was also updated. And here in the projects part, we have two applications. In shell, we can take a look that the builder is NGX Builder Plus, the new builder for the shell application, and also the port is 4200. For the micro frontend application, we have a little bit another situation, and the same builder NGX Build Plus, but the port is 4201. The next step is to configure our routing to make a connection with the micro frontend application. Let's go to the shell and to the app routing module, and here we have only the shell component and the second path, as we have it in template with the route mf, we expect to have micro frontend, and we will load it lazily also. Load children. And here we of course will not provide a direct way to this micro frontend. We will just mention that it will be MF and high module. Of course, this path is not known for us, and let's tell that let's declare this module. For that purposes, we will create a new file. It will be global.d.ts file, and declare module. The name of this module is MF high module. So now we are already done with the all configuration for the shell application and micro frontend application, and now it's time to run it. Let's go to the module federation directory, open it in terminal, and the command is npm run all. This command, with the help of the module federation, will build both applications. And firstly, our shell application will be launched on the 4200 port. But of course, we can also separately open our micro frontend application. But let's take a look firstly how it looks on the main port. And here we have two buttons. First one is our shell component, and this one is our lazy loaded micro frontend module high. And by pressing on the button, we are navigated to the route map when our high component from high module is already loaded. Let's go back to the shell, and we are returned to the shell application. Once more to micro frontend, and our micro frontend is loaded for us. So this is just a very simple example how we can create and configure the shell application and a part of the second application to make it like a front-end part and expose it and inject to the main shell application. In this video, we will tell about the new feature which was introduced in Angular, and we will tell about signals. Signals were firstly presented in Angular 16 in Developer Preview. And now it provides a new way for our code to tell a template or other code that the data has changed. And in common words, it's a wrapper around a value that can notify the interested consumers when the value has changed. And we can imagine it as value plus change notification. By the way, signals use our standard Zone.js for tracking and updating the view. Now, let's take a look at two ways of value assignment. And in the first example from the left side, we have the old one. This is variable assignment. From the right side is the second one. this is a signals creation. And the difference is in using parentheses. Under the hood, the signals value is always read through a getter function, which allows Angular to track where the signal is used. We can reference signal in the template also with parentheses, and when the signal is changed, the template will be marked as dirty and scheduled for re-rendering the next change detection cycle. On the bottom of the presentation, you can see the difference in the template when we're using just a variable or where we're using a signal. Now let's go to our Signals API. And to create a signal, we should call a function signal and just pass a value. Let's take a look at this example. All signals are separated into two types. The first type is writable signals, and the second type is read-only signals. And writable signals provide an API for updating their values directly. We can create signals by calling the signal function, and then we can change the value with using set or method update. And signals can contain any value from the simple primitives to complex data structures. In this example, we're passing 0, then we're changing it to the number 5, but also we could pass an array or any other type of object. When we want to change the value of the writable signal, we're just using the method set. And when we want to update the value, we're using the value update and passing a callback function to this method update. And the difference between the set and update is that when we change the value with set, we just pass a new value. When we use update, the update method recalculates the value of the signal based on already existed value in signal. So here, when we're using update, in value will be already existed number 5, and the new value will be calculated and assigned with the number 6. So this is the difference between the set and method update. Now let's go to the read-only signals. And also they are called computed signals, because to create a read-only or computed signal, we should use method computed and to pass a callback with a function which will compute the new value of the computed signal. And computed signals derives its value from other signals. It means that in computed signals we always have any other signal based on which the value of the computed signal will be calculated. The computed signals has some differences. First of all, they cannot be reassigned. It means that you cannot call the method set or method update on this double count. Also, the computed signals use caching. It means that the value of the double count will be cached. And double count's derivation function does not run to calculate its value until the first time double count is read. Once calculated, this value is cached, and future reads of double count will return the cached value without recalculating. When the count will change, it means that when we will pass a new value with the method set or method update, it tells double count that its cache value is no longer valid, and the value is only recalculated on the next read of the double count. As a result, it's safe to perform computationally expensive derivations in computed signals, such as different filtering arrays or any other heavy calculations. As I already mentioned, the computed signals are not writable signals. And if we would like to assign a new value with the method set or update, we will receive an error. So now let's create our first signal, and also we will take a look at some different use cases of the signals. And I want to use signal everywhere in template, in some methods of our app component. So I will here just mention the type of our signal. It will be writable signal of numbers. And in the constructor, I will call method signal and pass number 10. Also, I want to have the value of the signal in the template, and I will use a property binding. And to have a value from signal, I need to use parentheses. So now let's update. And we see 10. If now in our component we will change the value of the signal, it will be reflected in the template. And let's do it with the method set. And let's set 100. Now let's update, and we have 100 here. Then let's use method update. And as you remember, the method update required to pass a callback like a first parameter, where the value of our signal will be recalculated based on already existed value. And when the interpreter will execute this line of code, the value of the signal will be 100. And let's change it. And I want to plus 10. And here I expect to have 110. Let's take a look, and we have 110. Then I also want to execute some code asynchronously, and let's use set timeout. And in set timeout, in 4 seconds, I want to change the value with the method update, and let it be multiplied. Let's see. From the beginning we have 100, then 4 seconds, and it was changed to 1000. And everything is okay, because when our value in signal is changed, it is always reflected in our template, and the value in template is always updated. But the situation will change if we will work with the value of the signal and with the other values without binding in a template. Let's now create a new field in our class, and it will be a count. The type of count will be number, and we will calculate the count based on the value from the signal, and the value of the signal plus 5. And we expect that the value of the signal will be 100 plus 5. We expect to have here 105. Then in 4 seconds, the value of the signal will be changed and it will become 1000. But the value of the count will not be updated, and we can check it. If we will click on the button, we want to log the value of the count. And let's take a look. 100, we click. Our value of the count is 105. Then the value of the signal was changed, but if we will check the value of the count, it was not changed. So that's the problem, because the value of the signal was updated, but the other values which were calculated based on the value of the signal was not recalculated. And for that purposes were introduced effects. They are very similar with the effects in NGRX. And let's try to solve this problem we already have in our class with the help of the effects. And let's check now. We click first time, we have 105 in count. Then the value of the signal was changed. Now it is 1000. We click once more, and now the value of the count was updated, and we have a real one, 1005, based on the updated value of the signal. And effects always execute asynchronously during the change detection process. And also we should remember that the effect function requires an injection context. It access to the inject function, and the easiest way to provide this is call effect within a component, directive, or service constructor like we do it now. But if we want to call effect outside of the constructor somewhere in just, for example, in the method click button, we need to pass an injector to effect via its options, and it will be the second option. And firstly, we need to inject injector, and then we need to pass here the second parameter with field injector, and here will be our injector. And now let's check once more. From the beginning we will have undefined, and then when we will click it will be 1005. So now it works outside of the injection context, outside of the constructor, and this is another way how and where we could use the effects. And what about destroying effects? When we create an effect, it is automatically destroyed when the context is destroyed. It means that the effects created within components are destroyed when the component is destroyed. When the effects was created in directive or service, it will be destroyed when the directive or service will be destroyed. But also we have a way to destroy the effect manually, because effects return an effect ref, and it has a method destroy. Let's try. For example, we could create a variable here, and after the first execution of the effect we want to destroy it. We need to call the method destroy. Now we are going to start looking at standalone and new features which were introduced together with it. We will also practically build a small project to see it in practice. But firstly, I want to remind you how ng-module applications look like. And in Angular, ng-module is a decorator that represents a block of code that focuses on a specific functionality or specific feature of the application. It acts as a container for components, directives, services, and other related entities, providing a clear organization for the application's code base. Modules can be lazy loaded when they don't need to be available on startup stage, which improves the speed of the application. Let's take a look at the right side of the presentation, and here we have an example of an ng-module. And ng-module has a list of metadata, and first of all, it is a declarations array. And in this array, we add components, directives, and pipes that belong to this ng-module. In imports, we have other modules, those exported classes and services are needed in this module. In exports, we have the subset of declarations that should be reusable in the component templates of the other ng modules. In providers, we have a creators of services that this ng module contributes to the global collection of services. And in Bootstrap, we have the main application view. It is an entry point called a root component. It hosts all other application views, and only the root ng module should set the Bootstrap property. With introducing standalone, the architecture of the application became more simple, and as a standalone could be component, directive, or pipe. And standalone is, in this context, means that it can be used without declaring it in any module in declarations array before it will be used, and it makes using modules optional. Firstly, standalone was introduced in the 14th version of Angular as a developer preview, and in 15th version it became stable and can be used in production applications. Its aim is to substitute modules in future and gives us an ability to use more simple syntax. To make a component standalone, we need to add field standalone in the component decorator. If this component was used in any ng module in declarations array, we should remove it from that place. If this component is also a main application view and it bootstraps, it will be also removed from the bootstrap array. And first of all, we need to pass it in bootstrap application function in main.ts file. With the introducing standalone, like a new feature in Angular where we can independently use components, directives, and pipes without declaring in any ng module, another new features were also introduced. And let's go through this list. First of all, now we can bootstrap standalone components and provide the configuration as the second parameter in bootstrap function. In this way, we will provide the dependencies on platform level of the module injector. The second one, we can lazy load standalone components. Previously, only modules could be lazy loaded. And then we can lazy load configs with roles, which has lazy load standalone components. And also, in standalone projects, module injectors was substituted by the environment injector. And also, now it is possible to create environment injectors programmatically with create environment injector function. And now let's tell more about the substitution of the module injector by the environment injector. And making ng modules optional. Now it requires the new way of configuring these module injectors with the applications-wide providers. In the standalone applications, it means that in the applications which were created with the Bootstrap application function, these modules providers can be configured during the Bootstrap process in the providers option. And this new way of the bootstrapping and the new Bootstrap API gives us back the meaning of configuring these module injectors without using ng modules. And in this sense, the module part of the name of this module injector is no longer relevant. So that was decided to introduce a new term, environment injectors. And environment injectors can be configured differently with using one of the following configuration. First of all, it was saved the possibility to configure it in ng module providers. And this is for applications bootstrapping through an ng module like in old way. The second one with the decorator injectable with the provided in. And it could be used in both applications, in ng module based and in a new just only standalone applications. The third one is a provider's option in the Bootstrap application call, and it is also only for fully standalone applications. And the fourth one is a provider's field in a route configuration. And together with the introducing standalone and substitution module injectors by the environment injectors, also we received some changes in dependency injections hierarchy, and now it became more complex. Let's take a look at this example. And here, first of all, we have a standard old component. It is a data picker component. It is declared in our module, also on our old standard ng module in declarations array, in date in declarations array. Also, it is exported because we plan to use data picker components some way in the other modules or in the other standalone components if it will exist. And also, calendar service is provided like a dependency for this ng module because maybe it will be used some way in a data picker component. And then we have a new component which is standalone. And here you can see that we use in template of the standalone component our old data picker component. And to have an ability to use this old data picker component, we need to import data picker module. And here, when Angular creates a standalone component, it needs to know that the current injector has all the necessary services for the standalone component dependencies, including those based on ng modules. Don't forget that with in ng module, we have a calendar service, and it is needs for our standalone component. And to guarantee this dependency, in some cases, Angular will create a new standalone injector as a child of the current environment injector. And today this happens for all Bootstrap standalone components. It will be a child of the root environment injector. The same rule applies to the dynamically created standalone components also. And a separate standalone injector is created to ensure that providers imported by a standalone component are isolated from the rest of the application. And this lets us think of standalone components as a truly self-contained pieces. In this video, we will build a standalone application with rows and lazy loaded standalone components, touching all new features introduced together with standalone. But firstly, in the very beginning, we will generate the module application and then convert it to standalone manually and further develop it with standalone approach. So let's generate a new application. Okay, it was successfully initialized, and I will navigate to this folder. And what we have here, we generated in a old way application with two modules. The first one is app module, the second one is app routing module. And our first task will be to migrate from the module approach to a standalone. And I would like to start it with the app component. And let's make this component a standalone. Then I want to serve the application just to see what kind of error will we have in terminal. And the first problem is that app component is standalone and cannot be declared in an ng module. And if we will go to the app module, of course, we see that app component is mentioned in declaration in compilation scope, and we should remove it from here. And at the same time, app component is a component, our main component, which bootstrap the application. It means that it is the first entry point, the first main view for the bootstrapping of the application. And of course, we could not mention anymore in ng module. And it means that now we should bootstrap the application in another way. Let's go to main.ts, and this old syntax is never need for us. We should remove it, and for now we should use the other function bootstrap application, and the app component will be the first argument to this function, because from app component now our application will start, not from any module. Let's clean up a little bit our dependencies. The next problem we should see is connected with the routing, because we added routing from the beginning when we built the application. Let's take a look that now the router outlet is not a known element, and we also need to make some changes connected with the routing module. Let's clean up this HTML file. I want only to leave router outlet here, and I also want to add some context. I'm an app component. Okay, and as our standalone component substituted the ng module, it is very logical that we should import the routing just directly to this component, and also we need to import all other dependencies which are a need for our application. And in imports, we should mention, first of all, the common module and the router module. And then let's go to app routing module, and we also remove ng module from here. And now we will export just a constant from this file. And it will be an array of routes. And then let's return to main TS. And now, like a second parameter, we could mention the routing. And we should have here an object with the field providers. And in providers, we provide an array of our providers, or just a function provide router. And we pass a constant which we exported from the approuting module.ts file. As now it is not a module, we should rename this file, and let's make it app routes.ts. Then we could remove app module. We never need this file. And I think that now everything should work fine. Let's check. And we have a content from app component and no any errors in console. You see that now there are no any module in application, and we are bootstrapping the application just directly from app component. So now it's time to add some context for our application, and we will generate some components which also will be a standalone components, and they will be a components for the routing. And let's navigate to app directory, and here I will generate a new component and let it be chat component, and also we should add a flag standalone. Okay, let's take a look. It is standalone. We imported common module also here. And now we want to use this app chat in app component. For now, this element is not known because we need to import chat component into the app component. And let's check. Chat works. So the next our step will be to add here also some components in chat, and let it be maybe a header, ng generate component header, and it will be a standalone. And we want to generate header in chat. So I would use this command. So header is generated, and we should use in that way it here. And we need to import header component, header component. Then in header, I think that I would like to add a navigation panel. And here it will be something like this. We will have a main container navigation panel and two elements, home and users, and it will be our roles in this header. Then let's generate these components, and it will be in G generate component. I want to make it on the level with the chat component. And it should be also standalone. And the next component, which is users. I want to add some styles to the header. And let's check. You see now we have two elements here, two components, home and users. And now I want to configure the roles, and in chat directory I want to create a new file. It will be chat roles.ts file, and here I will export a constant chat roles. The type is the array of rows. And I will provide here the first path. And for empty path, I would like to have a component, home component. This is just like in a standard to old applications here, nothing new. And then let's go to app roles. And here we need to provide a component with for empty row. It will be component chat component. Let's check. Okay, we need to remove here. And chat component should not be now imported here. And maybe I want to add some context now just to understand that it works. Chat component. And let's check. So now I would like to configure the chat roles, and the path with the home will load home component. And then I want to also to configure the users row. Here we will load users component. And then let's go to app roles. And here I want to lazy load the configuration of the chat roles. And I will do it in a known way. We should import. The path is chat roles.ts. And then I need to load a module, but it will not be a module for us. Now it will be a configuration of the chat roles. And also we should not forget to import a router module here, router module. And also I think that we should add some global styles, and with the asterisk, I want to have margin 0 and padding also 0. Let's check. So now if we will go to the home road, let's check. Okay, we should also to use here a router outlet. Now let's check. If we will go to the users route, it will be users work. Let's clean, go back, check once more. Home, we have homeworks and users route also works. So now a little bit simplify the configuration, and as this is a default, we can export the default as a route array, and now we can remove this part in then. Let's check. And also we should lazy load separate components, and maybe let's do it with the home component. And for that purposes, we can use a function load component, and then it will be in that way that we usually lazy load any routing configuration or modules in the past. And we will import and we want to lazy load home component, and in then we will retrieve component home component. Okay, let's now check. And let's take a look to the network tab to see that our home component will be loaded only in time when we will navigate to this component. And here we see that the chat component was loaded only in time when we request it. Then let's add some simple functionality. For example, I want to have processed the case when the path is empty. I want to redirect to the home, so it will be always the start of the routing, and path match is full. Okay, and also let's go to the header template, and I would like to add here a router link to be navigated to home. You see that we're importing routing link to the header component, and the route will be home. And I want to navigate to users like this. And in header component, you see that we imported routed link because it is a standalone component and it needs to import everything that needs for this component. Let's check. When we have no path, we are automatically redirected to home. We go to users and go back to home. So in this example, first of all, we have a bootstrapping of the standalone application because our app component is a standalone, and our application now starts not from the app module like a first entry point, but we are starting from the standalone component. Then in chat routes, we used their configuration with the lazy loading of the components. Previously, in the old architecture of the applications, the only modules could be lazy loaded. And also in app routes, we used the way when we lazy loaded the configuration of the routes in which the standalone components were used. So in this example, we summarized a lot of new features which were introduced together with the standalone. In this lecture, we will tell about service workers, its principles of work, and will practically use it in our own project. So service workers is a proxy between the web application, the browser, and the network. And adding a service worker to an Angular application will be the first and the one step for turning an application into a progressive web app. Service workers are based on promises and require HTTPS protocol for security reasons, but we also can work with service workers on localhost. And the main task of the service workers is to intercept all outgoing HTTP requests made by the application, and service workers can choose how to respond to them. For example, they can query a local cache and deliver a cached response if one is available. And proxying isn't limited to requests made through their programmatic APIs such as fetch. It also includes resources referenced in HTML. And by the way, the service workers work are not independent from the server-specified caching requests. And the service workers leave after the user will close the tab, and it means when the next time the browser loads the application, the service worker loads first and can intercept every request for resources to load the application. And if the service worker is designed to do so, it can completely satisfy the loading of the application without the need for the network. It means when the user doesn't have a network connection, but the application was already cached by the service worker, this cached result will be returned for the user like he has the working network. So, if to summarize, the main purpose of the service workers is to cache the requests from the application and return the cached results. And also it is differ from the server caching. And service worker could fully work in offline when the network connection doesn't work. And service workers have the several life cycles, and firstly it is downloaded, then installed and activated. And now let's take a look at a practical example. Let's make our own service worker and touch the different functionalities are available when we have service worker in application. Let's go to the IDE. And here I have an Angular application, and to add a service worker to the application, I need to use the command ng add Angular PWA. So it was installed, and let's check the changes which were added to the project. First of all, you see that we have a manifest, web manifest file. And here there are settings for the progressive web application. And if we will make a fully progressive web application, here we will have some settings for the icons, their sources, sizes, and colors for the icons. Also was added a new file ngsvconfig.json, and here there are changes and settings for the service worker. And also some changes were introduced in the Angular JSON file, and the most important one are the next. The manifest.web manifest file was added to the assets, and it means that it will be included into the bundle size. Also, was added an GSV config path with the settings for the service worker and service worker with the flag true. And also, for the tests was added the manifest.web manifest file. Then the changes were added to the app module config, and now in imports array, the service worker module was registered, and by default, it is disabled for the dev mode. And we have a default registration strategy, and it means that the service worker will be registered when the application will become stable or after the 13th second. So now let's compile the application, and to have the service worker working in the application, we need to launch a server, and it is advised in documentation to start server on the base of the compiled files. So I've added a new command in package.json, and we make a built-in production mode and launch the server on this port. And let's run this command. So the server successfully started, and we can check our application. And you see that everything works fine. But in the application tab in service workers, we do not have any service workers registered in the application. That's because, as I already mentioned, we need to have the HTTPS protocol or work on localhost. So now let's go to localhost and let's now check. And now you see that we have service workers registered for this application, and it's fine. What we can do here, for example, we have an offline mode, and it means that now this application is cached, and if we will lose the internet connection, the application will be loaded from the cache, and we can check. We see that everything works fine, and if we will go to the network tab, we can see that some files were loaded from the service worker. Also, we could check the offline mode if we will unregister the service worker and we are in offline, but there are no any service worker registered for the application. So we have no internet because the network is turned off. To return the cached version of the application, we need to return the online mode, refresh and receive the newest version of the application. Now this version is cached once more by the service worker, and we can launch the offline mode once more. Now I want to check any other cases with the modification of the content in the application. For example, we want to substitute the context in this file, and I want to just to have a simple hello. And as we changed the data in the application, we need to recompile the file because the new files should be compiled with the new hashes. And let's rebuild the application. Okay, so the application was recompiled, and we have the new files with the new hashes. And now let's open the new instance of the application. Let's close the previous one. And you see that we received the outdated version of the application because this context and this content never exist. And the problem is in service workers because once more the service worker returned for us the cached version of the application. But at the same time, the newest version is already available. And if we will refresh now the application, everything will be fine. We see the updated content in the application, but it is not so logical for the users when they will receive any version of the application, they will start working with this version and they don't know that something new somewhere available and they will continue working with the outdated version. And how we should deal with this situation. Let's go back to the app component and to avoid the situation when the new version is available but the user works with the outdated one. We could work with the class SV update and let's inject it via constructor. And here we should call the method which is named version updates. And it's a stream of the events. And when the web service worker will load the cached version of the application, then it starts to check if the newest version is available. And as it's a pipe, we could is an observable, we could subscribe to the events from the version updates. But in this subscribe, we will receive a lot of different events, and not only connected with the real already existed new version, which is ready to be loaded for the user. We will have in stream a lot of other events with the checking, with the installation of the version, and so on, so on. So I think that we need to filter this stream, and in pipe we will use operator filter, and here will be an event, and this event will be filtered by the type, and we are interested in type which is named version ready. It means that the newest version was uploaded and is ready to be updated in browser. And in subscribe, we will, if we want to work somehow with the event, we can do it. But in our case, I would suggest just to send a confirmation for the user if with a notification that the new version is available for this application, and if the user wants to reload the app. So let's make a simple confirm, and that text will be the new version for the app is available. Do you want to reload? And if the user wants to reload, we could call the document, location, and method reload. Okay, now let's change once more the content updated version. Then let's recompile the application once more. Okay, let's open in new tab it. We have, you see that we have hello, this is an outdated content. And let's wait until the confirmation will be received to answer OK. And now let's check how it will work. So we refreshed, or we can open it in a new tab. And you see that we have this confirmation that the new version of the app is available. Do you want to reload? OK. And the application was updated with the new version. But also we could make a check-in just for example, every 2 hours if the new version is available, and if it is available, to ask the user if he wants to reload the application. And we can do it in a very simple way. We could create a timer and let it be a timer for 2 hours. We could subscribe to it. And here we also will work with the SV update, and we need to call a method check for update. And it's a promise, so in then we could repeat the very similar functionality with the confirmation or any other information for the user, and the possibility to reload the application. And also in these videos, I want to tell about the push notifications, as it is a very important functionality that is used very frequently. And the service workers also provide us an ability to push notifications to the users, and we can do it very simply from this API. We could push data here, press push, and the user will receive the push notification. And for that purposes, we need to inject here a special class SV push. And to receive the data from the push notification, we should call the method which is named messages, and it's an observable, and we could subscribe. And now I want just to log data which will we receive from the push notifications. And to push something from here, we should of course provide the data in special format, and for us this is a JSON format. Let's create a simple JSON. And we should not forget to recompile the data, recompile the application each time when we change something in code. Let's go back, refresh. OK, and press push. And you see that we have in console the data which we pushed with the push notifications. But this way of working with the push notifications is not the way we expected to have, because of course we want maybe to have a push notification somewhere from the right side of the application or from the left side, or we want just to use simple default browser notifications. And to start working with the push notifications in that way, we should follow the special API. And now I'm showing here this API. It should be notification with the fields title, body, icon, and click action. And to start working with this API, we should use the class notification. And the method is called request permissions, because first of all we need to check if the user has the special permissions to receive push notifications. And this is a promise, and in then we should check if the user has these permissions. Permissions is equal granted. And if yes, I now just want to log a simple string, show notifications. Okay, and let's recompile the application once more. Also, I'm copying the JSON. Okay, let's refresh. New version. Okay, and we are pasting here the new JSON. We press push, and now you see that we have a default push notification from the Google Chrome. We have title here, test push notifications. So in that simple way, we could organize the push notifications in the way we want to have. So we could have in our code any special code with the special functionality which will show these notifications from the right or left side of the application with special styles, or just use a default notification from the browser. So web workers are used for running any script in the background threads without interfering with the user's interface. And if you have any heavy computations on your user side, like we have in this example, you can use web workers to do the heavy tasks while allowing the browser to give your users a smooth and better experience. In the other words, we can remove something or retrieve something from the main thread and move the calculations to the other thread, to a web worker. And when the calculations will be finalized, we should return it to the main thread without blocking the user interface and code execution. So let's do it now. I'm in app directory, and now I will generate a new worker with the ng web worker, and let's name it big int. So the new file with the biginter.worker.ts was generated. And with the generation of the new file, we can see that some changes were done in the Angular JSON. And first of all, in the build options was added the field with the web worker tsconfig. And also was added a tsconfig.worker.json file with the conditions for building the web workers, and in the include section we have the mask for the building worker.ts files to be included in our final build. And let's go back to the app component.ts file, and the main problem lies in this function, and to use it somewhere in the other thread or to call it somewhere in other worker, I would like to move this function to the any separated file and export this function. I will create here a new file. It will be big int.ts file. And I will remove this functionality to this file. It will be a function export function set big integer. We will return the first value. And now what we do then. So here we will create a new worker, and let return the function for this class, and we will create a worker new worker. And the first parameter, we should set the URL for the worker. The second parameter will be import meta URL. Okay, now we need to post any data to a worker, because our workers work with the post message and event listener. It means that when we want to start execution in any worker, we should post a message to this worker. And when the task will be finalized, so when worker will calculate our value, it will also send a message to us with the help of the post message function. And on our side, in the main thread, we should add an event listener just to have an ability to read the data which was posted by the worker when it finalized the calculation. So let's call the function post message, and just for testing purposes, let's pass a string to the post message. In worker, you see that we will retrieve the data from the message, and here we need to make our heavy calculation. Set big integer, and we want to post this big integer from the web worker. And to read the value which was posted from the worker, we need to add event listener. So I think that that's it, and we can check how it works. And also, as when we added a web worker to the application, our Angular JSON was updated, and not to have a problem with the compilation of the application, we need to rebuild our application. And now let's take a look how it works. If you remember, when we clicked on this button, everything was frozen until the new value will not be calculated. Now I'm clicked and nothing was frozen. We just received a new value when it was calculated by the worker and returned to the main thread. I could do it once more. You see that everything works fine without stopping. Okay, and now it once more was updated and everything works fine. So it was the main purpose of the web workers just to improve the performance of the application and to move some heavy computations, some heavy calculations in the other thread, not to block the user interaction with the interface.